हमारा कौन सा हॉल होगा?
आपको मेल आया रहेगा, तमाम 6 मेल भेजा है।
ये हॉल ये करके लिखा है पर प्लानरी सेशन, और मैंने अभी लॉग इन हुआ, कुछ दिख नहीं रहा यहाँ।
जब आप लॉगिन करो,
हाँ,
अभी हॉल के में लॉगिन करना है। अभी हॉल के में चलना है लॉगिन करके।
हॉल ए का कुछ प्रोग्राम नहीं आ रहा है।
अपने यहाँ पर करके देखें। तो प्रोग्राम तो चल रहा है, अभी आ भी जाता है। तो लॉगिन पर एक बार आप दोबारा लॉगिन करके दे दीजिए।
हेलो,
प्रोग्राम चल रहा है पर आप दोबारा करके दे दीजिए। आपने जब तक वो मुझे आपको लिंक भेजा है तो हॉल के में क्लिक कीजिए।
सी प्लीज ज्वाइन ऑल ये कहाँ है? प्लानरी हॉल ये करके कहाँ है?
आपका मेल आया नहीं करूँ।
नहीं, जो उन्होंने लिंक भेजा उसी से मैं ट्राई कर रहा हूँ।
चारों हॉल के हैं सर,
नहीं, ये सीधा स्क्रीन आ रहा है, प्लीज ज्वाइन ऑल हॉल ये फॉर प्लानरी सेशन, लेकिन हमारा ज्वाइन करने के लिए, क्लिक करने के लिए ऑप्शन नहीं है।
हॉल का ऑप्शन नहीं है आपके पास।
हॉल ये लिखा है, कोई हाइपर लिंक नहीं है, सीधा वो टेक्स्ट मैसेज है।
टेक्स्ट में आके नहीं तो टेबल टाइप सर आप ईमेल कीजिए तब फॉरवर्ड कर रहे हैं आपको लिंक।
मेरे को ईमेल नहीं है, वो भेजा था अनिल सूद ने। कौन, कहाँ से आया मेरे को ईमेल? कौन भेजा होगा? कौन सा ईमेल से भेजा है?
तो राजू किसको भेजा आपको? राजू को भेजा आपको। सर आपका ईमेल राजू @gmail.com पर फॉरवर्ड कर रहे हैं।
हाँ हाँ
हेलो,
हाँ, करिए।
फॉरवर्ड भेज दिया आपको।
हाँ हाँ, स्टार्ट हो गया। हाँ, कौन सा हॉल सी में? ठीक है ठीक है ठीक है। ठीक है ठीक है। Hello. Hello.
Hello, sir.
Yeah. Hello. Somebody there can speak out.
Yeah, myself. Yeah. Speaking.
I am PL and Radhu. You are able to hear, no?
I am able to hear, sir.
So this is the session I supposed to join as the chair of the session.
Yeah, you have to join, sir, the same session. You are the chairperson of the session.
No, who are all there in that? Who is chairing? Who is co-chairing or anything?
Sir, you are chairing the session,
Uh-huh.
and Dr. J.P. Singh from PAU, Punjab Agricultural University, will be co-chair.
JP Singh. No, he has joined already or not?
Yet not, sir.
Yeah. Who is speaking?
Dr. D.C. Losali, sir, from Punjab Remote Sensing Center.
Just a week I called me, no? Sorry. So,
Yeah.
Yeah, this thing, Saliji, this, I have some other program at 12 o'clock. So, maybe,
Sir, we will try to finish before that. Sir, you can leave at that time. Whenever we have to.
Okay, please. Yeah, sorry for that.
Excuse me, sir. Am I audible?
Yeah, you are audible. Deepa, Dr. Deepa.
Yes, sir. Okay.
You are audible.
Okay, thank you, sir.
Okay.
इसमें select कर
सर हम लोगों को तो एक स्पीकर जरूरत होगा हम लोगों को तो एक स्पीकर जरूरत होगा इसलिए हम चाहता है एक मंथली बेसिस
हेलो
सर
ये क्या क्या पेपर्स है, पेपर्स का लिस्ट है क्या?
सर आपको कल शाम 6 बजे एक मेल भेजा था आपको वो। हाँ सर आप ज्वाइन करिए
कब भेजा था?
सर। कल शाम 6 PM का मेल है, yesterday evening.
कैन यू फॉरवर्ड अगेन?
ओके सर, जस्ट
ये क्या सेक्रेटरी आईएससी आईएसजी एलईसी आया क्या?
सेक्रेटरी आईएसजी से कल शाम मेल भेजा ना, 6 बजे जो मेल भेजा उसको फॉरवर्ड कर दो डॉक्टर बाबू को अभी।
नहीं, सेक्रेटरी उसी से आया था क्या?
हाँ जी, हाँ जी
सेक्रेटरी
सर, दोबारा फॉरवर्ड कर रहे हैं सर।
हाँ हाँ।
राजू राजू PLM का डिटेल ऑफ प्रेजेंटर।
ये 6 पेपर है वही है ना? हेलो
Sir, number 2 is not presenting. Those 6 papers are there.
5 है मतलब?
5 प्रेजेंट होंगे सर। सर देर
अभी
आर
11:15 हो गया, स्टार्ट करेंगे क्या?
हाँ सर, को चेयर डॉक्टर JP सिंह इज ज्वाइनिंग जस्ट। तो ज्वाइन
वो
करते हैं
मिल
सर।
गया मेरे को, पेपर मिल गया, मैंने देख लिया।
ठीक ठीक है सर।
ठीक है। Yeah, Dr. Losali,
Sir,
can we start?
sir, just I again call to co-chair.
हाँ जी सर। हाँ ज्वाइन हो गया। हाँ
Shankar, we are going to start. We are going to start. Start. Good morning to all. Good morning to all. Myself, DC Losali, as a session moderator. I welcome to chairperson of the present session, Dr. PLN Raju, and co-chair of the session, Dr. JP Singh. Now, if I will say that there were the 6 papers in this technical session 3B of water resources, out of which one confirmation I have not got confirmation from the Geomatics 3170 number paper, that is by Zayatu Kanta. Rest of the 5 papers will be presented. At the first, Dr. Avinash Kumar will be presenting, and the time allocated to the presenter is 8 minutes for presentation and 2 minutes for question answering. Please adhere to time, समय की पाबंदी रखिए, otherwise we will go out of session. Then the second presenter will be Rahul Sharma. Third will be Ankan Jana. Fourth will be Hussain Babu. And the last presentation will be by Dr. Deepa. Now, before we start the session, I would like to introduce the chairperson, Dr. PLN Raju. Dr. PLN Raju served for 33 years to the ISRO, out of which for the 28 years he served as IIRS, Dehradun, and for more than 5 years he served at the NISAC as a director. Presently, Dr. Raju is appointed as Special Secretary, Science and Technology in Climate Change Department and Director of Assam State Space Application Center. He was appointed on the September 2021. From September 2021, he is working there. He was graduated from in civil engineering from Massive University and MTech from Anna University, and he also did the certificate course from ITC Netherlands in 1995. And he served as in charge for the water resources, geoinformatics, head department group, remote sensing and geoinformatics groups, group head, program planning, evaluation. And
Dr. Lusali, not much introduction is required. Let time is given to participants. Yeah.
Okay. Sir, just sir, he has, Dr. Raju has trained more than 30,000 students or participants in the 8 years of service. He has visited a number of countries, and for example, Japan, Netherlands, France, Germany, Belgium, China, Uganda, Taiwan, Australia, Czechoslovakia, Dubai, Nepal, etc. Right? And in the last, I will say that he has been awarded and appreciated for the ISRS President Appreciation Medal in 2014, IIT National Geomatic Award application in 2016, ISRS National Satish Dhawan Award for lifetime contribution in remote sensing in 2020. And many more things. Dr. Raju, as the chair has said, that I have to give more time to the candidates. Then now the co-chair, Dr. JP Singh, is BTech from Allahabad University, MTech from PAU Ludhiana, and he has served for as assistant professor and then associate professor, and presently he is working as a professor in the PAU. His specialization is agriculture, drainage, water, groundwater application, remote sensing, and GIS. And he is working in the different research projects. At presently, he has full research paper 50 published in Proceeding 8, popular articles 4. This is the journal. Number of PG students, he has guided 12 PG MTech student and 2 PhD students. For the awards, he has got the Jawaharlal Nehru Award by ICAR, the Society of Recent Development in Agriculture Young Scientist Award, High Tech Horticulture Society Fellowship Award, Kumar Saxena Bahadur Award, Agriculture Engineering Division Medal for Best Research Paper Award for the Annual Convention of Indian Society of Agriculture Engineering, Agriculture Research Services. NET exam passed Senior Research Fellowship. He has got the PhD by Council of Scientific and Industrial Research. He is member of different professional bodies. Now,
गर्म पानी देंगे।
I welcome to both chair and co-chair along with the candidates who have to present the paper, and also those who have joined the present session. Now, I would like, with the permission of chair, I would like that Dr. Co-chair can give some remarks, and chair can give the remarks, please. Dr. Singh. Dr. Raju, can we start now? Hello.
Yes, sir.
Yes, you can start. Actually, I'll also thank this one Ludhiana chapter, ISG, ISRS, this thing for organizing such a event, national level event. As he has already mentioned 5 papers, I think they can go ahead. I think I request Dr. JP Singh Saab to overall coordinate and chair the session, because I also have to go in between. So if he should take it as a chair and then continue. I'll be there as long as time permits. With this, I'll hand over to Dr. JP Singh to coordinate and conduct the session, and also start the presentations. Yeah, over to Dr. JP Singh.
Okay, sir. Thank you, Dr. Saab. So start the presentation. Number 1, I think Avinash Kumar.
So Avinash, we have 8 minutes for the presentation and 2 minutes for discussion, question answering. These are the 2 time.
No, I am audible, sir. Hello.
Yes, you are audible.
Voice not clear. Avinash.
Sir, I am audible, sir.
Yes, you are audible.
Yeah, very, very low voice. Very low voice.
Hello. Hello.
No, very low. No, not audible.
Sir, right now I am audible, sir.
Your voice is very low. You are audible, but voice is very low.
Okay, sir. Right now.
जोर से बोलो अविनाश, आपकी आवाज साफ नहीं आ रही है.
It's okay, sir. Right now, sir.
Little bit okay.
So I am sharing my screen, sir. Sir, my screen is visible, sir.
The screen is visible, but your sound is very low, very much low.
Losaliji, in this case, what he can do is he can go for the next presenter. By that time, he can set right his audio, other things. Then we can come back to him.
Yes, sir. I'm
Better.
just. Hello. Yes, sir.
Let him restart and all the things, and then get ready. In the meantime, other presenter, I think serial number 3, I think he can take over and run.
I think he's ready, Rathab. I think just his voice is now clear, I think. Avinash, try.
Yes, sir. Yes, sir. Right now it's clear, sir.
Yes, it's okay.
Okay,
It's
sir.
okay.
So, good morning, sir. I am Avinash Kumar. I am currently SRF in Civil Engineering Department of Indian Institute of Technology, Guwahati. My topic is on the study the effect of meteorological parameter on surface water loss basin using cloud computing techniques. So first slide. This is the first slide in which there is a 5 photographs, and they basically work on the Rispana basin. So Seeker Fall photograph shows that is the source of water which the Rispana river is started, and the second graph shows that the Morthuwala, it's a confluence of the Rispana river, and 3 photograph, it shows the middle part of the river. We see is the lot of garbages and law of surface water. This figure is taken in the monsoon period, and it's a very low water in this river, sir.
Avinash Kumar, just I am stopping. Come to your title. Just I wanted to see our title is not matching. Come to your title.
Yes, sir.
Okay, okay, it's all right. Okay.
So this is my study area, sir. So it's river basin study area. This river is maximum elevation is 2,228 meter above mean sea level, and the all the area of the this basin is 58.78 square kilometer. And data used, the satellite data used in Landsat 578, and meteorology use precipitation, LST and AET. So there is a indices which I used. The base year where I am taken 1991, and the surface water, the indices used I MNDWI and EVI. There is some sort of equation like MNDWI is greater than 0 to 1. It's a or EVI is greater than 1, and 2 objective. After that, object no water water pixel and the water pixel. After that, we are creating a GIS database to identify the inter-annual water body variation and trend analysis from 1991 to 2020. All this process has this box. All the process I done through the Google Earth Engine. So there is a Google Earth Engine which I process in this one, and all the basic like quality pictures, image enhancement analysis, and all these things are done through the Google Earth Engine. It's a cloud computing methods platform. And this is a land use land cover maps 1991, 2005, and 2020. It's a 15 years of gap. We see that in the first image of 1991, we see there is 42% of forest, 13% plantation, and there is some 11% of water body and 15% of built up, and the crop land is 19%. In again 2005, that is a slightly slightly less of the 2005. There is some classes like 43%. There is less of 2%, and water body also decreases in this in the 2005, and built up is increase in 19%, and crop is 60%. Again, we are going through the 2020, sir. We have seeing that the forest is 33%, crop is 3%, and built up area is 64%. Is the drastically changes of the urbanization in this region, sir, basin. And the water body is almost 1 to 1% is available in this basin, sir. And this is the elevation distribution of Rispana catchment. We are seeing that the dam is 2,208 is the highest elevation, and low is 529 meter. And we see that the lowest part of this maximum part is the built up area in this region. We can see the 12.31 square kilometer area in this region, and the highest is 1.75 square kilometer. We see the there is a lot of forest area which is a reserve forest. We say that. And again, this graph says the variation and changing trend analysis of this all the scenario. We see the urbanization is increasing like a 60. We are taken on 1991 2005. and 2020, sir. And this is a line rate, it demarcate the before commencement of Uttarakhand and after the commencement of Uttarakhand. Means that the after the commencement of Uttarakhand, there's a lot of development in that basin area, sir. Basically the Dehradun district. And we see that the increasement, directly the vertical increasement of the urbanization after the 2005 to 6, sir, it's vertically going up. And again, we are seeing that the surface water area according to the percentage of urbanization, sir. We see that the urbanization is increasing after the commencement of Uttarakhand. We see the variation of surface water percentage is slowly going down, but little bit higher in the 2009 to 2010, but it will not keep a higher, it's going down, increasing right now, sir. And third graph says that the precipitation, we see the precipitation graph before and after the commencement of the Uttarakhand. A red dot says that the change point, this is a change point of rainfall, sir. You see that this is a change point after the commencement of Uttarakhand. Also, this is rainfall changes due to the urbanization increasing or something, this one. And fourth one is LST, sir. So LST is a two part. We have just see the before commencement of Uttarakhand, the first part, and second part is after commencement of Uttarakhand. We see the before the commencement of Uttarakhand, we see the average of the temperature is 23 to 25 between them. And just after the increasement of construction, maybe urbanization and population growth, all these things, we are see the 2.74 degrees Celsius is deviate, means increases after the development, means after the commencement of Uttarakhand, sir. And same reason is going on in the 80, sir, actually over transpiration. In this graph, we are seeing the also there we seeing the red dot shows that the changing point of this graph is in shows that after the commencement of Uttarakhand, sir. So this is all the scenario of the changing trade analysis and variation of this region of the Rispana Basin, sir. And this is a map of annual water surface variation map. We are seeing the 1991, 95, 2000, 2005, 10 and 20. You see the lot of water in this 1991 after 2095. And again in the 2005, we see the water here, but again it is slightly down, means trend is going down. And we see in the 2020 there is a very less amount of water as surface water is in this year of 2020. And the next slide is conclusion. In this conclusion, we see the graph. In this conclusion, sir, we see in the graph there is a this is a year trend, means 1991 to 2020, and annual water demand and population. And this side is urbanization growth. And we see the yellow line is a population increase line, growth line. And the blue line is going down. It is surface water depletion. Before, we are divided into two parts, like before commencement of Uttarakhand and after the commencement of Uttarakhand. And this shaded region is the increased water demand period. So we see that the most of the water period demand is starting from the after commencement of Uttarakhand, and again it's going down, means constant direction is going on. After the 2005, it will be going on a constant direction. So we see the demand of water is same, but the demand of water is increasing in the constant, but we lost the surface water due to the growth of urbanization, sir. And this is some points we have just taken. The maximum average variation is in the 30 years going downward, and LULC it changes 64% of the LULC is increased in 2020, sir, again to the 1991. And there is, I think, no much significance for the meteorological effect. It's basically we say the growth of the maximum urbanization and built up area of that region, its effect more. And the field survey is has been conducted in the post monsoon period and indicated the same that has been observed in the analysis. And some points in the future, sir, what we can do for this, a proper management policy for basin restoration and rejuvenation initiation should be taken, designed and implementation of all these Rispana basin, because this is a foothill foothills city of the Himalayan river. So we can say that this river is more important for the Dehradun cities. So we need to.
Please conclude.
And so thank you, sir.
Now the session is open for question.
Hello, Avinash.
Yes, sir.
Just tell me, after your study for the policymaker, because urbanization is in increasing trend.
Yes.
So what your study, you can say advice or study should that so that we can maintain the natural resources despite of increasing the urbanization. Because the past you can say then that will be decreasing everything, surface water decreasing, all this. Then how we can manage it?
Sir, this is I'm just studies all about this. The space technology means satellite based, but in the my point B is very necessary to rejuvenate the basins, water resources, because without the water we can't do anything. Sir, there's a lot of construction is I think going on, and those area which is reserved forest and the in the bottom part of the basin, we have to this part is not not used, sir. I'm going to this slide.
Just tell me in the few words, if the urbanization we cannot stop, how we can maintain that this natural resources and you can say surface waters, all these, without doing any you can say urbanization in the way this is natural, that will be go, nobody stopping.
So we can, sir, we can study more on near future for better management policy design, sir.
Okay. So anyone others, any question please? If no question, then we can shift to the next.
Now I will request Rahul Sharma present his Indus River Basin Reservoir water level changes, validation and comparison of the NASA borehole laser altimetry.
Hello.
Yeah, Rahul.
Good morning, sir. Hello.
Good morning. Good morning.
Am I audible, sir?
You are audible.
Okay, sir. I'm sharing my screen.
Yeah, Rahul.
It is visible now to everyone, sir? Hello.
Yeah, it is visible. Please do it a full screen.
First of all, good morning to everyone. Myself, Rahul Prakash Sharma, and I am currently working in Punjab Remote Sensing Center as a JRF. My present topic is to study the differentiate and comparative study between the satellite derived altimetry water body height with near real-time gauge data center. And my topic name is Indus River Basin Reservoir Level Changes. Validation and comparison of NASA spaceborne laser altimetry ISAT-2 with near real-time gauge data. First of all, as we all know that our land surface is a complex mosaic of geomorphic unit and land cover types, resulting in large variation in terrain height, slope, roughness, vegetation height, and topographic variation present in all spatial resolutions and at spatial scales. For that, inland lake and reservoir are the component of the surface water and plays a significant role in the hydrological cycle because it maintains and provides water for various humankind utility purpose like domestic use, agriculture purpose, industrial use, power generation, with the help of the hydroelectric power station. Moreover, reservoir water also provide some cooling components for the oil, gas, and nuclear power plant, as well as it also supports wildlife and aquatic ecosystems with fishing activities. At present, globally, lakes and reservoirs contains approximately 21% of the global freshwater among them. But currently, as per the international and national research, shows that there is a decline trend between 1984 to 2015, as there is almost about 19,000 square kilometer permanent water structure or bodies from the wetland or the surface water has been disappeared. But now, as well as the artificial lake boundaries, which is supposed to be built by the man-made utility purpose like reservoir, has also been come up with approximately about 184,000 square kilometer as a new reservoir. For this purpose, monitoring of lake and reservoir is very necessary to predict and to analyze the surface water level changes as in this climatic variabilities like and land use patterns, water demands from both water inflow and outflow in the terms of the precipitation and the water utility purpose for the man-made kind, which changes the volume of lake and the reservoir area uh, among them. Now, for this purpose, we have just correlated the data among the satellite derived means ISAT data set like ice cloud and land elevation satellite, that is ISAT-2, with the CWC Central Water Commission Gauge data centers station data. At three main objective is there to delineate the changes, water level changes among three major reservoir in the Indus River Basin, namely Ranjit Sagar Dam, Pong Dam, and Bhakra Dam. After that, we have derived the water level height from the ISAT-2 during the time period of 2018 to 2021 with 29 observation. And finally, we have computed the difference between the ISAT-2 water level height with the near real-time gauge data. And this is the study area. At present, this all the three major reservoir like as I have mentioned that Ranjit Sagar Lake Dam, Pong Dam, and Bhakra Dam, which is present in the Indus Basin among the sub-basin like Ravi River Basin, Bias Basin, and Satluj Basin. As we all know that the Indus River Basin is the one of the major river basin in the world, which consists of 11,65,500 square kilometer, and which shares the boundary between the India, Afghanistan, Pakistan, and China. In India, catchment area of the Indus Basin is 3,21,289 square kilometer, and which is shared among the states like Jammu and Kashmir, Himachal Pradesh, Punjab, Rajasthan, and Haryana, as well as the UP of the Chandigarh. In the left side on the screen, this is the study area means representing in Indus River Basin, which is derived from the hydrostate hydrolakes means basin boundary. And after that, you can see the three reservoirs for the present study analysis. First one is the Ranjit Sagar Dam, which is also known as the Ken Dam, and its current FRL means full reservoir level is 5 to 7.91 in both the active and inactive season, with also in flooding activity. Apart from them, next is a Pong Dam. Its current FRL is 4 to 3.67 meters. And after that, the Bhakra Dam, which FRL is 12.06. Next is the data used for this study analysis. Here we have proposed to compute the difference between the satellite derived ISAT to water level height altimetry data from ALT13 product with near real-time GOS data. Second one is like lake parameter, like the water level height, and is present from the laser altimetry satellite like the ISAT-2 with onboard sensor like Atlas. Currently, Atlas is also termed as the advanced topographic laser altimetry. And after that, we have this ISAT-2 dataset can be derived from the Open Altimetry web portal as well as MSIDC portal. After that, gauge data station set data has been acquired from CWC water bulletin for all the current dates. And these are the some key.
Mr. Rahul Sharma, come to result. Time is very less.
Okay. Okay. This is the methodology that first of all we have retrieved the mean auto level height from the ISAT 1213 product in the form of weak beams and the strong beams, and after that CWC gauge data acquired from the CWC, and finally we have computed difference between the weak beams from the ISAT 2 from gauge data and strong beams from the ISAT-2 from the gauge data. And after that, we have validated the water level height changes among both the data set. And as per 29 observation has been analyzed. And this is the result for the Ranjit Sagar Dam Dam. At Ranjit Sagar Dam, track 569 and track 714 from the ISAT-2 satellite pass from pole to pole have been utilized for this reservoir. Here we can see the orange and the green beams, which is represent as the strong and weak beams of the uh, uh, photons of the ISAT-2. And this is the study area means data observation. We have used from 2018 to 19, though 2018 data was little bit available, but we have almost derived. This is the first track means here from as you can see in my pointer, like 2019 to 2021 is for the track 714. Here there is a slight difference between the strong beam and the weak beams as compared with the CWC data. And after that has the track number 569 falls uh, slightly or between the reservoir. There we can see this means near about equal trend in this height. And this is the graph showing that the observation has been done on 1st May 2021. There we can see this equal height from both the data sets. And same as one as for this Pond Dam, although we can see this track number 1156 is falling asides of the Pond Dam. And this is the graph from the both the data set as well as the photon beams obtained
Rahul,
through
please
that.
conclude.
Okay, just a few minutes, sir. And this is the water surface height for this pond dam. And similarly, this is the same for the Bhakra dam. We can say that we can see that near about same means result has been observed from this dam. And this is the conclusion we have made that Ranjit Sagar Dam shows the RMSE error from both the strong beam and weak beam is about 0.5, and as well as in Pong Dam and Bhakra Dam. From both the dam, we can see that RMSE is less than 3.9, so that we can strongly use for this water level height derivation product from the ISAT to satellite laser altimetry satellite data set, and can be utilized for the water resource purposes. Thank you, sir.
Yeah, open for the question answer. Any question, please?
Yes, I have a question.
Yeah.
I am Ashwin Gujarati. Why there is a difference of this RMSE with changing of reservoirs, and how you have corrected the elevation difference of the elevation difference in the height, water level height when you have different tracks? Is there a difference between water level height in different tracks, or are all the same?
So there is a difference between as different tracks has different water level height products, and it contains of different beams. And similarly, gauge data sets center has though present station in between in the reservoir, though there will be a differentiate in results. Okay.
I'm Sharat Chandra. I'm having a question that when are you are using a product ALT13, is
Yeah,
it?
yeah,
Okay,
yeah,
so
yeah.
while people generally use only strong beam, these big beams are not used for inland water applications. And second thing, you will have a number of measurement within a reservoir. So are you taking a mean value to compare it
Yes,
with
sir.
the
Yes, sir. I'm using a mean value from all the data set, all
in
the
that
tracks.
scenario, your result may vary because sometimes close
Yes.
to the land there is a footprint, laser altimeter footprint will have a land contamination. So better you select only points that fall within the center of the reservoir. First thing,
Okay.
and
Okay.
second thing, into your graph, into particular time period, you are getting deviation from the gauge value. If you go to the graphs, why it is changing with time? Because some of the time the results are matching very pretty good, especially in the early period of time, but
Yeah.
later on when you are going for next year there is a large deviation. Any particular reason
Okay.
for that? Some other corrections you are applying?
Those are there will be a seasonal variation in present among them, though we can notice the height level changes between them, as the strong beams consist of strong photons data that
Hmm.
footprints can be means mean be height value will be more accurate through the weak beam.
Hmm.
At seasonal variation, presence of seasonal variation may vary with the data sets from both the strong beam and the weak beam data set.
Okay. Okay, but you can also select with the median value in place of going for the mean. Try
Yeah,
to select the median and then also compare your results.
okay, sir. This is the general purpose for the analysis that we have made.
Okay. Okay. Thank you.
The access.
Yeah, any question? Otherwise, we'll go to the next. So, next speaker, please.
Now, I request Mr. Ankan.
Yes, sir. Am I audible?
Yeah, you are audible.
My screen is visible.
Screen is visible. Make it full screen.
Okay. Good morning, everybody. I'm Ankan Jana. I'm working as a PhD research scholar at Malivira National Institute of Technology, Jaipur. Today, I am presenting about my work, estimation of daily evapotranspiration using remote sensing based surface energy balance method. So evapotranspiration is a very
Share
important
screen as full screen.
Okay.
Come to your methodology and result discussion because time is very less. Leave the introduction part. Do the full screen.
Still my full screen is not visible.
Your time is started and time is less, then just only give the background and why you are studying and then come to the methodology and result discussion.
Now, sir, full screen is visible.
Yes, go ahead.
Okay, sir. So evapotranspiration is an important thing. We need to compute evapotranspiration for heterogeneous area because our Earth's surface is heterogeneous. So we need to get one method which can easily calculate the ET for heterogeneous area. For classical methods, it is very difficult to compute the evapotranspiration for the heterogeneous area. So I selected the remote sensing methods, which is very good, or spatial information which also provided by the remote sensing method. So I took that methods. Those are some remote sensing methods which is available there. Is a surface energy balance algorithm for lands, simplified surface energy balance index, surface energy balance system, and metric and SSBOP provided by some renowned scientist and researcher. And as per the literature reviews, CIVAL is more appropriate for arid or semi-arid region. I have used the CIVAL method for my study. And this is the basic equation for calculating the evapotranspiration using the remote sensing method. It means latent heat flux equals to total net radiation subtracted by total soil heat flux and sensual heat flux. And this is my methodology chart. This is basically cover the CIVAL method. First, we have calculated the remote sensing data and have to prepare the inputs like LSTs, land surface temperature, albedo, emissivity, NDVI, SAVI, and also another inputs is there is digital elevation model. I have selected here Astra digital elevation model for my study. And after that, I have prepared net radiation. I have calculated the net radiation and soil heat flux. And then they are on hot pixel and cold pixel selection. This is very important, and those selection of pixel is very instantaneous on the calculation of evapotranspiration. So it is very it have to select the hot pixel and cold pixel very minutely. And for meteorological data, I have collected the meteorological data from India Meteorological Department. Mainly wind speed and air temperature data is used in that method. So I've used that, and after that I need some iteration to stabilize the DT value, difference in temperature, air temperature and surface temperature, and Morin Obukhov length. After that I can calculate the sensitivity flux, and from sensitivity flux using the that equation, latent heat flux equals to that main equation. I have calculated the latent heat flux, and from latent heat flux I calculate the instantaneous ET, and after that instantaneity I convert it to daily ET. This is a whole methodology chart for CIVAL. And those are some equations that can be used to calculate in CIVAL algorithm. This is for net radiation calculation, soil heat flux, sensible heat flux, latent heat flux. From latent heat flux, we can easily compute to instantaneous flux, but to compute ET24 means the daily ET, we need one net radiation for 24-hour net radiation. I compute that 24-hour net radiation as per basis one FAO reference crop evapotranspiration. I have used that method to compute the daily 24 hours net radiation. Those are some dates which for which the cloud-free data is available, and for CIVAL method it is mandatory to need cloud-free data, cloud-free remote sensing data I have used Landsat OLI remote sensing data for computation of CBAL, and those are some dates. 14 dates are I've got 14 dates cloud-free data from 2014 and 2015, and I have selected 2 stations. One station is Hisar and one station at New Delhi Pusa from IMD data, and I calculate the ET daily ET for those 2 stations, and those ET are showing that which I have collected from IMD. And I'm showing here one date, means 28th September 2014. For I have seen one scene 147 by 147, 144 path by row, and this is FCC image, and those 2 are the station location. And this is the ASTER DEM, ASTER digital elevation model, which I have selected for my study. And land surface temperature is one of the main important input for CBAL for ET calculation using CBAL. So I am showing here, and this is the overall. This is the daily ET. The last image is the daily ET for the date 28th September 2014, and I have calculated the daily ET for the for the scene and for the date, and it is clearly so that by using the remote sensing method, I can calculate the daily ET throughout the area. Even there is a part of homogeneous or heterogeneous. Throughout the area, we can calculate the daily ET. And those are some comparison between the IMD daily ET, which is provided by the IMD, and the CBAL method, calculated estimated daily ET. And it is clearly showing that the CBAL has more accurately compute the ET, and it has shown the very good result as compared to the conventional as compared to the classical methods available in the market, like bound ratio method and others. So we can use that CBAL method for a very large area, and we can get very good result using that method also. Those images are the regression plots for estimated ET and estimated ET and CBAL for those are the regression plots between IMD collected data and the estimated CBAL data. So it is clearly show that the R-square value coefficient of determination is very good for the estimation of ET using CBAL method. It's 0.91 for Hisar point and Hisar station, and 0.8 for New Delhi stations. So it is very acceptable. Now the conclusion part. Daily ET can be calculated very accurately using CBAL algorithm, and I have used Landsat OLI data, Landsat 8 data using the estimate of daily ET, and for 13 cloud-free days in that 2014 and 2015 we get, and R-square is very good for the Hisar and New Delhi station. So ET can be estimated using CBAL method with very acceptable accuracy, and CBAL is very suitable to estimate ET in a heterogeneous area, mixed land use land cover classes area. And those are my references. Thank you, sir. Any questions?
Okay, now it's open for the question answer, please.
Ankan.
Yes, sir.
You have done the ET estimation for Delhi and Hisar. You have compared that the IMD and CBAL. Right?
Yes, sir. Yes, sir.
As far as I saw the graph there, in the case of the Delhi. Yeah, here.
This one. Okay.
Delhi, there is in Hisar there is not much difference, but in Delhi there is too much difference. In Hisar, this is more or less similar values.
Actually,
Why
sir,
it is difference in Delhi?
yes, sir. In the CBAL model.
Yes. Your voice is. You have unmuted yourself, I think so.
Now it's okay.
Now.
I have selected the cold pixel and hot pixel. This is a very important part of the Siebel method, the selection of hot pixel and cold pixel. I have selected those two pixels nearer to the Hisar station. But that's why it's the same one image, one path and row image, which I have calculate the ET. That's why it's more accurate for Hisar region, Hisar station. If I selected the cold pixel and hot pixel nearer to the New Delhi stations, then it can be more accurate for the New Delhi stations.
No, can you give the? I want to know the reasons. Is there any reason for that? Why it is so? What was the?
So that's why the more uncertainties is there on the selection of that hot pixel, cold pixel, because hot pixel and cold pixel it provide the Landsat temperature value, which is further calculation, used for the calculation of ET. That's why when the distance from the point to the cold pixel to the anchor pixel is large, the uncertainty is there, more uncertainty is there. That's why.
Okay.
Yeah, Mr. Jana, just you just tell me I again in the same questions. If it is the difference at Delhi and similar to the Hisar, and how you can assure that this civil method will be, you can say, widely acceptable.
But sir, it gives us the acceptable accuracy, sir. For Delhi, it also provides us the regression plot shows us. For Delhi, it also R square value is 0.8. So it is more, it's acceptable, sir.
Then what the IMD, what the method using IMD for estimation of the ET?
IMD, that data provided by the IMD, mainly it's observed data as per IMD.
Then what the methods of for ET measuring the what IMD using which method? What are the methods? Which methods are using IMD for the ET estimation?
Sir, actually, I don't know. I have collected the data from IMD. Maybe.
So then you cannot say how you can say the traditional method is much your civil method is much better than the traditional method. What are the traditional method?
Sir, those are just like bound ratio method.
I'm asking you what are the traditional method? What are the traditional method?
Like sir, we have used here lysimeter in our institute. We have used here lysimeter to calculate the ET. But lysimeter is one particular station. He can calculate the ET for one particular station.
Exactly, I agreed with that. Lysimeter is one of the specific something. Then something is that you can say that will be based on the FO methods, and then FO method. There are lot of methods. Do you know about that? What are the best method that will be estimate the ET on the basis of energy balance, energy terminology? Which methods? What are the methods which use the energy term, energy balance, based on the energy balance?
Sir, I cannot understand. I think I don't know.
Then you said first you study what are the traditional. There are 4 or 5 traditional methods. Okay, after that, even the FAO also recommending for the Penman equations. Do you know about the Penman equation?
Yes, sir. I have calculated the reference crop evaporation using that method.
Then you go for the further study. For you have just compared with the IMD. You take one of the traditional. You take the recommended by the WHO Penman equation. You estimate it Penman equation and then compare with the Siebel.
Sir, actually for Siebel method, there need one reference crop evapotranspiration. That reference crop evapotranspiration I have calculated using that FAO crop reference evapotranspiration by I think Allen 1998. That formula I have used to compute the reference crop evapotranspiration.
Then just again you have confused. What is the reference ET?
That ET is used in the Siebel method to compute the ET for the whole area.
Therefore, that will be entire reference ET and crop ET, potential ET. That will be just you should know. You have taken the reference ET from the WHO, and again you are comparing with the you can say IMD. So you just required here before recommending you required one more method. You have to compare with that method, traditional method, and then you say this is the IMD and this is the traditional method, and then this is CIBIL.
But sir, we assume that IMD data provide us on observed.
No, this is not assumption. No, this is a very sensitive you can say parameter for the all studies, all agricultural studies. This will be the very sensitive parameter. It not depend upon only for assumption.
Okay,
So
sorry,
it is my suggestion. You
in
go
this case,
for
I
the
should have to
further.
contact IMD.
You go further and then find out the one traditional method, Penman equation, that is highly recommended by the FAO, and then compare it, and then you find out the result. Your comparisons.
Okay, sir. Thank you, sir.
ठीक है. Okay then. Okay. Any question, please? Otherwise, move to the next.
Request Hussain Babu to present.
I hope I'm audible to everyone. Okay. Just share my screen.
Your voice is very low.
Yeah, is it fine now, sir?
Yeah, now it is fine.
Yeah. Yes, my slide is visible, sir.
Yeah, your slide is visible. Earlier it was full screen. Now it has been shortened. Kindly make it full screen.
Yeah, it's full screen. Okay, let me start. Good morning to all. Myself, Hussain Babu from Atlantic Construction, and I'm here to present on the topic volume estimation of cutting and filling study using JIS.
Kindly make your slide full screen and speak somewhat loud.
Voice loudly, speak loudly. The voice is not coming clearly.
Yeah, okay, sir. Actually, it's already in full screen mode only. Okay. Is it fine now, sir? Okay.
Speak some loudly.
Okay,
and
sir.
make your screen full screen.
Sir, I already shared
Full
the
screen था अभी कम कर दिया आपने उसको full screen.
Presentation mode slide. Slide come to slide in presentation mode.
Is it fine now, sir? Is it fine now, sir? Is the JS and remote sensing are fast-growing technology in recent times.
In the beginning, it was full screen. Then you make it you make changes, and your voice is very slow. Speak loudly. Make it full screen. You have lost 3.
Okay, sir.
Hussain, will it take time?
No, sir. I'm just starting this.
Start now.
Is it fine now, sir? Is it fine?
Screen is not.
Just Is it fine now, sir?
Yeah, it is fine, but screen is not make it the PPT screen mode. Make screen full screen mode.
Some full screen mode only, sir, for me.
Sir, actually, the presenter, the organizer has to make the grids arrangement, sir. He has to drag and pull it down.
No, you have to make the full screen from your system.
Sir, it is already full screen, sir. The organizer has to
Need to arrange the grids.
Now it is full screen.
Yeah.
Start
Okay.
now.
Okay, I'll just stop. Okay, GIS and remote sensing technologies are fast growing in recent times due to its extensive applications in various sectors. In the construction sector,
On your camera is off.
is it fine now, sir?
Yeah, start.
Yeah, okay. Actually, estimation is a key aspect in any engineering aspects. So, for estimating the precisely in any construction activities will reduce greatly in greatly in time and cost. So, GIS is capable of doing this. Doing these things. So GIS is capable of creating actual terrain using the survey data and the excavation profile in the 3D as per the excavation plans, and so from which the exact quantity can be estimated. Um, This is a steady area which is located in Rihand Reservoir at Uttar Pradesh. Yeah, water intake structures is planned as a part of water distribution system for around that area. So yeah, for the construction of water intake structures, it requires a large, huge volume of excavation need to be done at that place. So. Um, so that with with the help of manual calculation or any other estimations, it's become quite complicated to estimate. So we are using the GIS technology to estimate the precise calculation for the precise estimations. So this is a methodology we carried out during for this modeling and estimation of cutting and filling required to fit the particular intake structure's planned location. So here we have collected some survey points, collected the survey points and contour levels for creating for modeling the natural ground level, and excavation plan is made. This is the excavation plan. Is designed to fit the intake structure with respect to the site condition. Here, in this case, as the steady area is along the water body, a coffer dam is required for the safer construction. So we estimated the maximum flood level of that reservoir at as a 266 meter, and the coffer dam is planned 267 meter. Can you able to see here? This is the coffer dam structures, and this is the excavation profile for to fit the intake structure. So these natural ground level with the natural ground level tin and DEM is created from the survey points. So, from the survey points that we have taken before the excavation, and we have created the DEM of about 10 centimeters spatial resolution as for the precise calculation. So this is this is how we created the excavation profile. This is the quite complicated process that we did in GIS. So here, when you check, this is a 3D plan which we created uh, from the excavation profile. So each line of its respective levels are fitted in 3D, and the ramp is created using the suitable GIS tools to make the slope along the intake structures, and the outer line of the excavation plan is uh, 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 is made from the natural ground level using using some GIS tools. A coffer dam also is created in 3D for for the calculation. From this plan, the tin is generated, and from the tin, DEM is generated for the excavation plan. So, using the cut and fill tool of ArcGIS software, we estimated the excavation quantity and the filling quantity required. So, this tool is basically calculates the volume using this formula. Is it will take the difference between the two cells at the same at the same location, and it will be multiplied with the cell area, and this is cumulatively added for the entire region of our study, and it will give us the results and attributes. So these are the results which we got for the study. So we have studied an area of about 10,448 square meter, and we have estimated as per GIS is 59,485 square cubic meter as for excavation, and 10,116 for filling volume. So actually, in this case, actually, usually for excavation purpose, we will be giving to another subcontractor. They will be charging it for it. So we need to convince them with the quantity because the vendor calculated is around 70,000 cubic meter, and with our manual calculation we got around 63,500 cubic meter, and with the precise calculation using GIS we got the estimation of 59,485 with the 3D modeling, to convince a subcontractor for our building, which have roughly we have gained around 20 lakhs for this particular activity. So this is the 3D model which we created for this. If any errors, chance of error is there, it is easily identified with the 3D model and can be rectified during the process itself. Due to this 3D modeling in GIS, that there is very less chance of error, and we can estimate the volumes with better accuracy. So for larger construction activities, this is a very useful technology, and we are mostly nowadays we are using this particular methodology for this estimation calculation, which could greatly reduce our time and effort, and it also we are saving a lot of cost by precisely estimating the quantities. That's it, sir. Thank you.
Okay, then question answer, please. Mr. Hussain, just tell me, you are just telling me the GIS method is much accurate, but you open your data, the manual and then GIS and then vendor. So
Yes,
that
sir.
is a lot of difference.
Yes, sir.
Yeah, yes, vendor and manual calculation. So how on what basis, how your validation is that? How you can say that GIS method is accurate method?
Sir, actually, after excavation, so, inside after the excavation, we will be studying for each level, sir. So that is matching our calculation.
Then matching with whom? What is the you can say validation? How to because manual calculation you have done, there will be some observation or something that you can
Yes,
validate. Ne? That you can say. So where that data?
sir, actually, manual calculation is done from another site planning team.
Okay,
So-
that's site planning.
Okay.
Then with which data you are comparing and then telling ki हाँ, yes, GIS is just close to this one, then this will be the accurate.
With respect to manual calculations, sir, because in manual calculation there are a lot of assumptions.
Right, so how you can say manual calculation will be the not accurate and GIS will be accurate?
Yes, sir, because due to the this irregular terrain format, there is a hill-like structures in that place. So for the manual calculation, there are a lot of what to say assumptions like their their interpolation will be like in a, like a straight line kind of things when they are calculating in manual things. So when you are modeling in 3D, those smooth curves and the spatial interpolation will get the better accuracy than the manual calculations. Actually, we are
So, okay, that is agreed. I agreed with that, but it is well known now. But how? Because authentic, you cannot say directly. You cannot say that GIS is the most accurate.
no, sir. Actually, for this
If
process,
some observation will not be, then how you can say that this is the GIS calculation and this is the actual that will be calculated or that will observe, then this is closed. Then in other method, vendor method and manual calculation is better than the GIS method.
actually, sir, the same methodology we have used for some like regular shapes kind of structures, sir. With like regular shape structures which can be easily calculated in manual with the manual calculation. We compared those calculations, it's matched accurately.
But I'm not satisfied with that because this is a
Sir,
well known.
Sir,
Sir, I'm adding to the points that I have said. As you may asking how we will verify when there is a dispute. Like, I have excavated more, we will ask for the proof, and we are own surveys also at times. When there is a dispute, we calculate using GIS, we manually calculate, and vendor also give a code. We compare it and we say using GIS. This is
now your voice is not coming. Hussain, and the second speaker voice, we are not able to, it's not audible.
am I audible now, sir?
Yeah.
Yes, sir. Sir, when there is a dispute where the difference in volumes and all coming, we generally go with the drone survey. Okay, and the drone survey, like when we propose the survey, we calculate it with the manually also in GIS, and we will give to the vendor for the calculation, and they will give the one value. So when we compare these three items, GIS is coming less. So we say this is the quantity which is on the field because we calculated using the natural ground level. Then what we do, we will give them the order and they also do the survey. And meanwhile, if there is any dispute, if there is a change in quantity, he is claiming for more quantity, it has been excavated and our calculation is wrong, we will deploy a drone survey where we get the present ground level using the survey drones, and we will calculate, we will subtract both the items for the earlier ground level and the recent ground level using the same tool, and it will give the amount of quantity that has been excavated.
Okay, it's all right, but as you can say, ki layman, then as a scientific way, even though you have calculated, but it is not validated. Just you use GIS calculation from which you are validating.
Sir, actually,
Main part is validation.
We validated with the regular shape
You
of.
are just this is your observation ki that is the straight line, and then drone survey, and then that will give, and GIS will give the accurate value, and then that will be the value accurate. So no need to do that. So you straight away you can say GIS such a tool that will give the accurate. Then no go further. This is the straight away. Whatever you will do, the GIS will give the better. But is it some validation is required? You have calculated then what from which you are validating.
Yes, sir, that is what I am explaining, sir. We have validated.
You have given three data. One is vendor, one is manual, and GIS.
Yes,
and just are simply saying GIS is best. I'm saying no, GIS not is. This is the manual calculation is best. Prove it.
Sir, actually, sir, in manual calculation, it is well known that there are a lot of interpolations required, sir. So that
okay, it's a lot of interpolation is required. Then what is the some actual? What are the things? Then that come that is required. That is go for that this one. Then you can say GIS that will give me that. Then how because your validation part is missing.
So actually inside we are calculating by layer. The actual site excavation done and the site is we are referencing to the, like if there is a, if inside if they are excavating to the level of some 170 meter, then that will be we are validating with our data that is rightly matching, sir. So actually, this process is not yet fully done. We are we are still in the complete validation, sir. This method we have validated with the regular some regular shape excavation, and it's matching matching with manual calculations also.
Okay, you think over that. I'm not taking much more time, but this is not. I'm not satisfied with the answer, and then just this. You can say method as this portions your GIS calculation. It's required validation. Okay, anyone?
Okay, sir.
Any other questions? Otherwise, if anyone more, then please next speaker, please. If anyone more.
Now I request Dr. Deepa.
Yes, sir.
Share
Yes.
his slides, PPT, and start presentation.
Sir, am I audible, sir? Sir, am I audible?
You are audible. Your screen is visible. And you start.
Okay, sir. Okay. Okay. Thank you, sir. Thank you, sir. Good afternoon, sir. I am Dr. Deepa Bhattacharya from Mahistala College Department of Geography, Kolkata, under University of Calcutta. The title of my paper is The Use of Remote Sensing Data for Major Morphological Changes and Terrain Attributes of the Gangotri Glacial Valley, Uttarakhand. Present paper is concerned with the remote sensing data for major morphological changes and terrain attributes of the Gangotri Glacial Valley. Landform dynamism states spatiotemporal changes of landforms under the influence of active endogenetic and exogenetic processes in the temperate climatic environment. And geomorphology is a scientific study of the earth's surface involving interpretive the description of landforms. This is the Gangotri. The study area has a great diversity of landscape with many striking contrasts of landforms which are the combined effects of structure, process, and stage. The Gangotri Glacier system is a cluster of glaciers comprising the main Gangotri Glacier. And the Gangotri Glacier is situated in the Uttarkashi district of Uttarakhand between 30° north to 30°55' north and 79° 4' east to 79° 16' east, draining in a northwesterly direction. It is about 30 km long and 0.5 to 2.5 km wide. And it is located in the first geomorphic unit, that is the greatly undulating glaciated zone of my study area. The total glaciarized area of the catchment is 258 square kilometer, and out of which the Gangotri system comprises only 109 square kilometer. This is the location map of my study area. This is the source of my location map is the list 3 images. And this is the Bhagirathi Peak, and this is the snout of Gangotri Glacier. The primary objective of this research work is to study and analyze the remote sensing data for major morphological changes and terrain attributes of the Gangotri Glacial Valley with remote sensing data. In order to fulfillment the objective of the research work, I have adopted modern methodology, procured the necessary data, information, and evidences. Post-field study involves the processing of raw data, tabulation, preparation of diagrams, finalization of maps, etc. And at first, the study-related maps were collected from different government organizations, like topographical maps from Survey of India, Dehradun, and satellite images from NRSC, list 3, list 4 images. And this is the location map of Gangotri Glacier Trough and our other tributary glacial troughs. The Gangotri system is a cluster of glaciers comprising the main Gangotri Glacier, and the glacier has 3 main tributaries, namely Raktabarno, Chaturangi, and Kirti. This is the contour and profile maps. The contour and drainage map prepared with the help of list 4 images. The map showing the river Kedar Ganga and Rudra Ganga at Gangotri River. Kedar Ganga joins with Bhagirathi near Surjakund waterfalls. This is the profile of Gangotri Glacier and Meru Glacial Trough. In Meru Glacial Trough, there are so many major breaks of slopes are observed. This is the tributary glaciers and digital elevation model of Kedar Ganga basin. These are some satellite imagery of Chaturangi Glacier, Raktabarno Glacier, Meru Glacier, Bregupond Glacier. And these are some profile I have prepared from accumulation zone of Gangotri Glacier and from the ablation zone of Gangotri Glacier. Next, I come to the point that is this is the image of Gangotri Glacial Retreat. A comparative analysis of the glacier snout position was carried out using data from primary and secondary sources. Interpretation from various satellite imageries over the past 3 decades. I analyzed the rate of retreat with the help of the GPS study and satellite image list 3, list 4, and Survey of India topo sheet using ADAS imaging softwares. The glacial area was calculated using satellite imagery and topo sheets from 1962, 1976, 1997, 2005, 2018, etc. Based on the intensive field survey and the analysis of the satellite imagery and also Survey of India topo sheet, the Gangotri Glacier receded 1429.30 meter from 1962 to 2018. That means long years, such as 49 or 50 years. And this is a very common and natural phenomenon, but we cannot neglect the interference of human activities, particularly to this glacier. Every year, thousands of tourists, pilgrims, mountaineers, and trekkers visit the area and have left huge amounts of waste material there. Thus, there is an immediate task to prevent any type of human activity except scientific research work to preserve this holy place, Gangotri, and to maintain its aesthetic beauty. Thank you, sir. Thank you.
Any questions? Dr. JP Singh. Hello, sir.
Hello.
Yes, sir.
Any question, please? Hello, any question? Just from my side, just Deepa, just you tell me, you for the application part for your study to the policymaker.
Sir, please tell me once again, sir, application part.
What the application of your studies in respect of the policymaker?
Sir, actually, due to the increasing population pressure in Uttarkashi town and its adjacent areas, settlement area is increasing rapidly and the area of agricultural land is reducing. the area of fallow land is increasing. Due to landslide and soil erosion, many of the agricultural fields have been converted into the fallow and wasteland also. Then, and the policy makers and the planners implement also the eminently desirable activities as well as the suggestions, recommendations. It has gained momentum in view of several attractive aspects of Uttarkashi and Gangotri area and strategy concerning integrated resource utilization, both scientific and societal, towards the achievement of sustainable development. And the researcher likes to give the weightage on the implementation of the suggestions on drainage basin strategy for integrated resource development. And the area has a great potential for economic development also, and as it is well enriched in varied natural resources, and there is a great scope for ecotourism also.
So just you tell me just on the your view point of view, what will be the immediate measures should be taken for the sustainable development of agriculture, sustainable agriculture?
Yes, sir. Actually, management of natural resource base with emphasis on conservation, enhancement, and sustainable and equitable utilization, leading to augmentation of the livestock production system. And the agricultural department can approach the farmers with suitable cropping pattern by selecting semi-tolerant to tolerant crops with the existing length of growing period, especially in hotspot areas. And the most urgent rural infrastructure should be more health accessible and better education facilities, which would help the human resource of the Himalayas. And the local communities could also be involved in the intensive management of the grazing areas and restoration of degraded habitats. Such activities would help in participatory wildlife management in the study areas.
Which year of your study? Which year satellite you have used and which year of the study?
Sir, I have used list 3 and list 4 images, sir, and which I collected from NRSC Hyderabad. Personally, I have collected this, sir.
For which year?
Sir, 1997, 2005, 2017.
Achha, last you have taken the changes of 1995 to 2007 and 2017.
Yes, sir.
Last one is 2017.
Yes. I have used, sir, 2 or 3 satellite images and one topographical maps, which is 1962, and the total area. Yes.
In 1962, okay, topographical map.
Yes,
okay, this is from my side.
Survey of India.
Thank you very much for the right way. Yes,
Thank
any
you,
other, please? Anyone?
Thank you, sir.
So, if no any question, then we are end here. So, Dr. Lasali, please. Dr. Lasali. Hello, Dr. Lasali. Dr. Lasali. Hello. Dr. Lasali.
Sir, coordinator will be coming. Please wait 2 minutes.
Yeah.
Sir,
Dr. JP Singh, I think you should go ahead. Dr. Tochali is unable to connect.
yeah. So now
We should
I
not
am
waste
able
our
to.
time.
Now I may connect. Now,
Thank you, sir. Thank you, Dr. Saab. And then we are over. Finish here.
now, sir, we are over. Now it is time to firstly honor the co-chair. Hello.
Okay, sir. Okay.
Sir, it is time to honor co-chair.
Thank you, sir. Thank you.
Now, I would like, on behalf of National Symposium, I would like to honor chair of the session. It is time to honor the chair. Now, I am thankful to chair and co-chair, along with the presenter and the audience who were present in this session. Thank you. Thanks to all.
Thank you, Dr. Saab. Thank you very much.
It visible. Hello.
Hello.
Ah,
Yeah, it is visible.
you can hear my voice clearly now.
Yeah.
Anyone want to check PPT presentation?
Yes, can I share now?
Yes, if you want to check, please share.
Yeah, yeah. Yeah, yeah, I would like to. Is it visible?
Yeah, yes, perfect.
Oh, thank you, thank you.
Good afternoon.
Yeah.
Yeah, I'm going to share my presentation. Just check
Yes,
it whether
yes,
it is visible.
please go ahead.
Is it visible?
Yes, sir. Yes, sir. Yes, visible.
And full screen mode, it is visible?
Anji, yes.
Okay, thank you.
Good afternoon, sir. Can I check once?
Yeah, go ahead, ma'am.
Is it visible?
Yes, ma'am, it is.
Thank you.
Full screen mode. Yes, perfect, sir.
हेलो हेलो मेरी आप
Yes, sir. Yes, sir.
यस सर
Hello, Satveer.
Yes, sir. Yes, sir.
Yeah, you can check your PPT.
Just a wait, sir. Is it visible, sir? Hello?
Yes, sir. Yes, sir. Perfect.
Okay, sir.
Yes.
Okay.
Good afternoon, sir. So, sir, can we start the session?
Good afternoon, Dr. Vishesh.
Good afternoon. Good afternoon, Dr. Chaudhary. How are you?
Fine. How are you doing? Fine.
Very fine.
Good
Very
health?
fine. Very fine.
ठीक है?
Yeah, good. All well.
Okay, good afternoon, sir. My name is Sumit Kumar. I am working as a scientist in PRSC. So this is a T3C Geosmart water resource session. First of all, I welcome Dr. Rajesh Vashisht. So Dr. Vashisht is a former Director Agriculture and Farmer Welfare in the Department of Agriculture and Farmer Welfare, Punjab. He is also Chief Conservator of Soil and Water in the Department of Soil and Water Conservation of Punjab. He has also worked as a Joint Director Agriculture in the Department of Agriculture and Farmer Welfare. Dr. Rajesh have a 33-year of experience in the field of hydrogeology, geophysics, groundwater exploration, investigation, conservation and management, irrigation, water use and management in agriculture, soil erosion, rainwater harvesting, and recharge, enhancing the water use efficiency by laying the underground pipeline systems, especially in the low pressure and low head gravitational flow in the e-governance, etc. So Dr. Vishesh has undertaken many projects like expansion of salinity in aquifer of Punjab, strategy for sustainable water use, long-term economic growth in Punjab, and crop planning for optimal use of water to realize a high productivity of income command area in rehabilitation of Kotla branch. So I welcome Dr. Rajesh Vishesh for this session. Our co-chair is Dr. Om Prakash Chaudhary. He is a principal soil chemist and head of the Department of the Soil Science in Punjab Agriculture University, Ludhiana. So his research area basically is soil chemistry and fertility, working on soil and water salinity and alkalinity for the last 30 years. His research was focused on the quantifying of the impact of poor quality water on soil health, crop productivity. Dr. Chaudhary includes efficient use of water for the poor quality and underground water for the sustainable productivity of cotton, wheat, sunflower, canola. He has also awarded with many awards like ISS Golden Jubilee Young Scientist Award in 1994, Agriculture Scientist Award in 2013, ICAR CSSRI Excellence Award 2017, FAI Golden Jubilee Award of Excellence in 2020 in the field of nutrition. I welcome you, sir, for this session. So, sir, for this session, there are 7 presentations. Out of 7 presentations, 4 are from student category and 3 are from general category. So, I request you to, sir, can we start the presentations?
Yes, please.
So, sir, our first presentation will be of Ajaz Ahmed Pare. He is presenting snow melt contribution to the stream flow in the upper Jhelum basin using isotropic signature. So, Ajaz, please share your PPT.
Good afternoon, everyone. Is this presentation visible?
Please.
Yes.
Okay.
Please go ahead. Please go ahead. It's visible.
Okay.
You
Thank
are
you.
audible.
Good afternoon, everyone. My name is Ajaz Ahmed Pare. I'm from University of Kashmir. Today, I'm going to present my paper on snow melting contribution to the stream flows in the upper Jhelum basin using isotopic signatures. In mountainous catchments dominated by the snow melt and the glacier melt, the estimation of stream flow sources has become increasingly important, as the domestic agriculture and irrigation activities depend mostly on these water resources. Identification of snow melting contribution in the stream flow is also important in order to get a precise idea about the impacts of depleting cryosphere on the stream flows under changing climate. So in the present study, we have used isotopes of water like oxygen isotope and the hydrogen isotope, which have been successfully used as naturally occurring hydrological tracers to estimate the contribution of different water sources to the stream flow. This is the study area of my research where Leather watershed, Kothar watershed, Bringi, Sandran watershed, and the Vishu watershed make the main tributary. And this is the flowchart of the methodology that I adopted. So first of all, we did the seasonal isotopic sampling across these watersheds, and also event-based sampling was carried out to collect the snow data and the precipitation data, and also the groundwater data. Then these samples were analyzed for oxygen-18 isotope and deuterium isotopes. And after generating this data was incorporated in the 2-component isotope-based stream flow partition method to generate the snow melting contribution. And this is the instrument which is called the Picaro water isotope analyzer, which has been used for generating the measurements of oxygen-18 or oxygen-16 per mil concentrations and deuterium isotope in per mil concentration. After generating the data from this instrument, we then incorporate in a 2-component isotope-based stream flow, which is given in here, and to generate the stream melting contribution to the stream flows. Now come to the results part. We have observed that different stream flow sources have different isotopic signatures, which makes it helpful to identify their contribution to the stream flows. Like here, we can see that snow isotope data shows more negative values of delta 18O and delta D, compared to the groundwater isotopes, which shows higher values of delta 18O and delta D and rain isotopic data. So different isotopic stream flow sources show different isotopic signatures, and they are helpful in identifying their contribution to the streams of the watersheds. The present slide shows the isotopic signatures of delta 18O and delta D observed in these 5 watershed streams during winter season. And we can see here that the other watershed shows more negative values compared to the other watersheds. And during spring season, all the 5 watersheds shows lower values in both delta 18O and delta D, which is a clear indication of the snow melt injection to these streams during spring season. And also here, Leather watershed shows more negative values compared to the other watersheds. And during summer season, we have collected the snow isotope data, and it shows higher values because, as we know, delta 18 O per it is a ratio of delta 18 over delta 16. When temperature increases, the 16 oxygen 16 gets more evaporated compared to the oxygen 18 because it has its mass is higher. That is, its mass is lower. Sorry, oxygen 60 mass is lower. That is why it is getting more evaporated than that. That is why it is the snow you collected during the summer season shows higher values of delta 18O and delta T. And during summer season, the watersheds exhibited the same trend. Here also the other watershed shows more negative values compared to the other watersheds. After generating these data sets, we then incorporate it in the two component hydrograph separation to generate the snow melt contribution. And we found that the watershed shows 59% in spring season and 68% in summer season. And Kuthar watershed shows 44% in spring and 11% in summer season. Bringi watershed shows 45% in spring season and 32% in summer season. And Vesho watershed shows 33% in spring season and 38% in summer season. And Sandran watershed shows 29% in spring season and 15% in summer season. And from this, we have concluded that snow meltwater is the significant source to the upper Jhelum basin stream flow during the spring and the summer melt seasons. And we have also found that other watershed stream flow shows maximum contribution from the melt. Thank you.
Dr. Chaudhary, should we have the questions right now, or should the questions be taken at the end of the session?
I think we can have questions now for 2-3 minutes, 2 questions or 3 questions, because otherwise the relevance of the presentation will be diluted.
Right. So in case anyone has any question, most welcome. Any questions, please?
If others don't have any question, I have one small question.
Yes, sir.
Can you show me the conclusions, please, Ahmed?
Yes, sir.
Azaz Ahmed, please. As you have used this discrimination ratio, isotopic ratio.
Yes, sir.
And snowmelt water is generally known to be the source of the flow.
Yes, sir.
Otherwise also, without
Yes, sir.
doing for it, right? So, I mean, can we put a number or can we quantify its contribution? How much? Like 60%, 70, 40, 30, whatever. Based on your data, based on your study. Otherwise, snowmelt water is the main source of Jhelum, upper Jhelum.
Yes, sir.
You might be knowing more than me.
Yes, sir. Around 60% it shows.
Am I
In,
right?
yes, sir. Leather basin. Yes, sir.
Yeah, I mean, your data as well as your conclusion are not showing the quantifying fact of your technique. You
Yes,
know,
sir.
you are using to quantify the contribution.
Yes, sir. Actually, sir, the snow data usually shows the higher negative values, isotopic values in isotope oxygen 18 and hydrogen isotopes. That is why, because whenever there is a when we collected the samples from the streams, this shows the negative values. Means that more major contribution is from the snow.
And the other thing I want to know, you have written two terms: snow melt water.
Yes, sir.
As well as snow melt. What
Yes,
is the difference between the two?
Sir, it is the same.
The first conclusion you have written, snow melt water is the significant source, and the second you have
Actually,
done
it is a typo mistake. Snow melt water is same. Melt water from the snow packs. Yes, it is a melt water from the snow packs.
So you have specifically told about the leader watershed. How about others?
Sir,
is it?
Sir, because their contribution in spring, they have a little contribution about, I have mentioned there, 45%. But in summer, the snow is already exhausted there. But in leather watershed, the snow remains up to September, sir.
Okay.
Yes, in rest of the watershed, the snow is already exhausted. That is why.
Yeah, Ajaz, I have one query.
Yes.
Ajaz, you're showing this the percentage of snow melt contribution to the various streams during spring season and summer season.
Yes, sir.
what is the extent of the data you have collected over the years? Does it vary or is it constant?
Sir, it varies. Yes, sir. Because this time I have shown only the year 2019, but it depends on the temperature also. If the temperatures are high, then it is showing different readings. Yes.
And what about the rainwater?
Yes, sir. Rainwater usually shows enriched values because when a moisture source evaporates from a body, so first the delta 18 means oxygen 18 because its mass is higher, so it will precipitate first. That is why it shows enriched values compared to the rest of these sources.
Okay. Did you study the relationship between the snowmelt water and the rainwater contribution
Yes, sir.
to the
Usually,
seepage?
usually rainwater here in Kashmir.
Just let me complete my question.
Yes, sir. Yes.
Did you study the relationship of the stream flow and contribution to the groundwater? How much snowmelt contributes and how much rainwater contributes to the recharge to the groundwater?
I am working on that. Yes, sir. Because I have to collect a lot of data. Yes, I'm working.
Thank you.
Because also it needs a 3-component separation technique. This time I used only 2 component. We will incorporate electric conductivity because when we have to consider 3 components, then we have to use another tracer. Yes.
So do you have
just a minute?
Sorry.
Speaking
Sorry.
from
Go
data list.
Go ahead, please.
Yes, sir.
Ajaz,
you want to say something?
Ajaz, I just wanted to inquire whether your Kashmir University has all these facilities of isotope.
Yes, sir. Yes, sir. We have facilities here. Yes, sir.
Great.
Yes, because then it also the precipitated sample does the collected sample does not also get it doesn't get evaporated when it get collected because we then analyze it within a day. Yes. Next day we analyze it.
Ajaz, you have concentrated your study basically on the contribution of snow melt.
Yes, sir. Yes, sir.
Ajaz?
In this paper.
Yeah. Can you listen to me?
Yes, sir. Yes.
Am I audible to you?
Yes, sir.
So now look at Qatar, like right in summer, the contribution from snow melt according to your calculations is 11%.
Yes, sir.
Right. It means the rest about 90% or so is coming from rainwater.
Rain and groundwater. Yes, sir. Combined rain and groundwater.
Rain and groundwater. Okay.
Yes.
Okay. Now, do you think that groundwater is contributing to the this river?
No, sir. Rain is contributing the river. Rain is contributing more. Groundwater is contributing lesser.
Dr. Shish, your comments on it?
Yes, it is possible.
Your take on this?
Yeah, it is possible. You see, groundwater contributing to the river is possible because of the kind of topography Kashmir has.
Okay. Okay.
Not a lot of streams flow
into
the rivers.
Yeah. Okay. Okay. Sumit, can we move to the next speaker?
Thank you, Ajaz. So our next speaker is Tariq. He is presenting on the evaluation of various glacier inventories over northern western Himalaya using Kashmir University Glacier Inventory. So Tariq, you can share your slide.
Are the slide visible?
Please go ahead.
Yeah. Good afternoon, everybody. This is Tariq Abdullah. Basically, I'm a research associate.
Doing slide mode.
Okay. So is it now okay?
Okay.
Okay. So good afternoon. This is Tariq Abdullah. I'm basically from University of Kashmir and I'm working as a research associate at the university. So I shall be talking about evaluation of various glacier inventories over northwestern Himalaya with respect to Kashmir University Glacier Inventory. So basically, as we know that glaciers, they are very sensitive to the climatic conditions and have been, in fact, have been selected as an essential climate variable by the GCOS, that is Global Climate Observing System. So this has basically invoked interest among the scientific community to have comprehensive change estimate of glaciers over at global level as well, particularly in the Himalayan region, for which a glacier inventory is a prerequisite. And in fact, the glacier inventories have been generated since early 90s or late 80s. But though most of the early glacier inventories, they were basically based on aerial photographs or field surveys, and they were restricted to smaller geographical areas. But with the advent of remote sensing technology, we had good data sets both at spatial scales as well as at good spatial as well as temporal scales. So a number of glacier inventories at global as well as at regional level have been compiled, and these glacier inventories were found useful in simulating or assessing various processes, various hydrological as well as climatic processes. However, when we use those global or regional glacier inventories at local scale impact assessments, so there are a lot of uncertainties because the Himalaya itself, there are a number of uncertainties or the number of environmental factors that basically affect the inventory or compilation of glacier outlines that include the debris cover, huge debris cover on the Himalayan glaciers, the topography of the remoteness or the topography of the glaciers itself, the shadow cover, and the seasonal snow conditions that are basically some uncertainties or the hindrances that basically prevent to have an accurate or precise global or regional glacial inventory. So in this regard, we basically the aim of our study was to have an accurate or improved glacier inventory over the northwestern Himalaya region. Basically, this region is one of the regions where we find the largest glacier coverage over the entire Himalaya in general and the Indian Himalayas in particular. So we wanted to have a glacier inventory over this region where we used primarily the Landsat satellite images that were then supplemented with field knowledge or field surveys of some glaciers over different basins. Then we used additional data sets, supplementary data sets like Google Earth satellite imagery, digital elevation models to complement or to supplement the glacier outlines. And we tried to have a precise or accurate glacier inventory over the region. And then we tried to compare our glacier inventory with the existing global or regional glacier inventory so that we can evaluate the accuracy of those glacier inventories. So besides the basic parameters in a glacier inventory like glacier area or its topography, we try to compile or supplement our inventory by providing information on debris cover that is non-existent or it is incorrect in the existing glacier inventories, or we try to have provide information about snowpack and other glacier parameters, including the thickness change of the glaciers over the region. So the study was basically carried out. We have primarily selected 3 basins in the northwestern Himalaya that include the Jhelum Basin, the Suru Basin that is in the Ladakh region, and the Chenab that is basically shared between Jammu Kashmir and the Himachal state of Jammu and Kashmir and the Himachal Pradesh. So we have used, unlike the semi-automatic approach or automatic approach used by the existing global or regional inventories, we use it and we preferred a manual approach to map the glaciers, though it is a bit laborious and tedious. However, it has certain advantages over the automatic or the semi-automatic approaches. And we use the data sets from Landsat satellite images that were acquired during 2000 and 2002. So then we tried to map those. We mapped the glaciers from these satellite images. Then we supplemented the data, supplemented the glacier outlines from the data with global digital elevation model, as per global digital elevation model. Then we also used thermal data so as to improve the accuracy of our glacier outlines. And we used field survey on some limited glaciers. The number of glaciers is basically limited where we carried out field surveys, but it helped us to generate a sort of interpretation key to map accurately the glaciers in the city area. Then we tried to have an uncertainty assessment of the glacier inventories, both of the existing glacier inventories as well as our own inventory. Then we compared with the existing as glacier global and regional glacier inventories, both in terms of glacier number, glacier area, and we also used an index that's overlap ratio that basically gives us an indication how well the outlines from our inventory and the other inventories, they basically overlap each other, or how accurate the how well the global glacier inventories and our inventory match. And value of one indicates that there is a perfect match between our inventory and the other inventories, and a value of 0 indicates that the outline doesn't match at all. So these are basically some statistics of our inventory as well as the glacier statistics of other inventories. As you can see, based on the Kashmir University glacier inventory, we have 144 glaciers in Jhelum Basin that cover an area of around 86 square kilometers. Similarly, we have 328 glaciers in Suru Basin that cover an area of 488 square kilometers, and we have around 2,700 glaciers in Chenab, 1,600 glaciers in Chenab Basin that cover an area of around 2,700 square kilometers. So if you can see over here, the number as well as the area in other inventories over the region, it vary significantly. For example, in case of RGI for the Jhelum Basin, the number is 234 compared to the number of glaciers that were mapped in Kashmir University glacier inventory. And I will discuss these discrepancies in next slide. So this is basically the hypsography or distribution of these glaciers, both in our inventory as well as in other inventories. If you could see that majority of the glaciers, in terms of their size, in terms of altitude, they are located in a particular altitudinal band. For example, in case of Chenab and Suru, the glaciers are largely distributed between altitudes 5,000 and 5,500. However, for Jhelum Basin, it is around 4,000 and 4,500 to 5,000. Likewise, you could see over here that majority of the glaciers, in terms of their number or in terms of their count, they are the size category, that is the size class that is less than 1 square kilometer. It has the majority of the glaciers. However, in terms of glacier coverage, the area class that is 1 to glacier area size category, that is 1.5 square kilometer square, has the largest glacier coverage. Similarly, the slope categories from slope ranging from 10 to 30 degree have the highest glacier coverage, both in terms of number as well as in terms of area. And most of the glaciers in all the inventories, they are northerly oriented, both in Kashmir University glacier inventory and other glacier inventory. So this is basic information about the distribution of the glaciers in the steady region in KUGI and across different glacier inventories. So then we tried to further have some more statistics about the glaciers based on Kashmir University glacier inventory. We found that most of the glaciers in the Sitedi region, they are facing the north aspects. However, there are certain contrasting topographic features, like the glaciers on the southern aspects, as expected, because the temperatures on southern aspects are quite high. So we expect the glacier at higher altitudes where the temperatures are a bit lower. And we have observed that the average glacier size was larger on the southern slope compared to the northern slope. And it was again due to the fact that the southern slopes they were found gentle compared to the northern slopes. So they provide a base to settle for the snow to settle down and convert into glaciers. So as you can see over here that the slope as well as the slope is usually gentle compared on the southern slopes compared to the northern slopes. Also, we tried to have map the debris cover extent of these glaciers, which is either missing in the existing global glacier or regional glacier inventories, or it is inaccurate. So we found that 8% of the glaciers are debris covered in Jhelum Basin, likely 13% were found to be debris covered in Suru Basin and 14% in Chenab Basin. So again, we find that the debris covered glaciers, they were located at gentle slopes and they were at lower altitudes, and it's quite obvious that at gentle the glaciers that were at higher altitudes, they have steeper slopes, so that they don't basically allow the debris to settle down. So at lower slope, at shallower slopes, the debris is basically.
Please conclude. Time
Okay.
is over. Please conclude.
Yeah, I'm just. So this is basically a comparison of our inventory and our different glacier inventories. As you could see, there are significant variation between KUGI and other glacier global glacier inventory. So these are this is an example of uncertainty that has been observed in the global glacier inventories. As you could see that the outlines, they vary hugely, significantly across different glacier inventories, and these are some of the reasons of that we try to highlight that are basically the reasons of these uncertainties. As you can see over here, there were some non-existent glaciers that were mapped on the global glacier inventories, but on the field they were not basically there. So this is another cause of the uncertainty in the global glacier inventories, that some of the glaciers that are basically in a single connected glacier, but it has been divided in the global or the regional glacier inventories. Again, this is one of another important source of uncertainty in the existing glacier inventories. The debris cover portion has been completely excluded from the existing glacier inventories. So in our study, we just included or tried to improve this uncertainty, and we included the debris cover portion of the glaciers in the inventory. These are some field photographs of some of the glaciers that we visited over last several years, and these glaciers basically helped us to generate an interpretation key so that we can have an improved glacier inventory over the region. So these are some broad conclusions from the region, and we observed that the number of the glaciers in Kashmir University KUGI is lower compared to other glacier inventories, and it is because of the reasons that I have highlighted previously. So majority of the glaciers, as I have shown, that they were found in low, they have smaller size, and the most large glacier coverage is distributed across the area size class, that is 1 to 5 square kilometer. And we observed that there are a number of reasons or factors that have resulted in the uncertainty of the glacier inventories, that include the seasonal snow cover, debris cover, as well as the shadow on the glacier surfaces. So we hope that the improved glacier inventory over the region would help research community for various glaciological, hydrological, and climate change applications over the region for better assessment and quantification of these processes. So with this, I conclude my presentation. Thank you.
Thank you, Tariq. Any questions, please? Can we have any questions? So Tariq, there is one observation from my side.
Yes.
As per your work, you explained that the manual system is much more robust than the semi-automatic or automatic system.
Yes, sir.
So that means we should more rely on the manual interpretation of the imageries, and secondly, the ground truthing is very important.
Yes, sir. So basically, if we could have developed some method that is supported by extensive field ground truthing, so the semi-automatic or automatic methods can also be quite robust. However, if we are trying to have assessments at impact estimate at local scale and mount glacier and have to incorporate glaciers as an parameter, so at that time we should have a thorough check of the existing glacier inventories or the inventories that are derived semi-automatically or automatically or semi-automatically, or it is better to have if the geographic area is small, then it is better to have glacier inventory that is developed manually. So at times the semi-automatic method is something like that. We do it automatically, then we try to correct it manually. However, we have found that the method itself takes a lot of time. So at times, manual approach takes less time compared to when we are generating the glacier inventories manually and then trying to correct them, generate the glaciers automatically and then trying to correct them manually. So at smaller scales, it is always better to have glacier inventories generated manually. However, at regional or global scale, we can still use the existing glacier inventories that have been generated using semi-automatically or automatically.
Thank you. Any observation, Dr. Chaudhary?
My only observation, Tariq, about your presentation is you took too long for material methods and other things, and the last 2 minutes you used for conclusion and your results. And even then, using that much time for introduction and material method, you couldn't tell the advantages the Kugi will have over other methods. You use that in conclusions. That is, my observation, because my thinking was you should have told the edge of your inventory or your system methods, as you now were referring to Dr. Vish's observation. My point was that you took too long to explain things, but still you missed the major part, because that is what was needed.
Yeah. So basically, I was about to explain that where I was explaining the uncertainties, but due to shortage of time, so I just rushed over those slides. So the factors that I just explained that have
some of the lines in conclusions. You use some of those lines with this when this is better in Kugi, but I think the results should have been part of your conclusion, and based on your results, you should have made conclusions. Rather, you are now adding concluding statements. You are giving the advantages of your method used. That's my observation.
Okay.
Sir, your mic is muted.
Sorry. Yeah, Tariq, I think you should take note of Dr. Chaudhary's observation, and this will help you in your future presentations.
Yes, yes.
Thank you.
Okay.
We can have the next presentation, please.
Thank you, Tariq. So, sir, our next presentation is from Ashwin. So, he is presenting comparison of the performance of multi-remote sensing indices in delineating surface water extent. So, Ashwin, please share your presentation.
I hope I am audible and my slides are visible to everyone.
Yes.
Today I will be presenting on comparison of performance of multiple remote sensing indices.
Dr. Ashwin, just closer to just come to close your mic. Yeah.
With me, we have Vibhuti Bhushan Jha, Dr. Ramarao Nindamuri, and Dr. R.P. Singh as my co-authors. So 70% of the world is covered with water, but only 0.7% is available to 7.7 billion people as fresh waters in lake, reservoirs, wetlands, and shallow groundwater aquifers. And monitoring of surface water bodies is very essential for sustainable water resource management. And we have found that satellite remote sensing has been widely used as a reliable and cost-effective techniques. Several algorithms and techniques have been developed for retrieving surface water extent, but index thresholding is the most popular ones. Water as a spectral target is highly variable in space and time, and spectral signatures of waters varies as a function of sediment load, algal content, depth, and bottom reflecting signals. Consequently, identifying the threshold yielding the highest accuracy is very challenging. Several multispectral remote sensing indices have been developed to accurately map the surface water extent, but difficulty lies in the selection of threshold, as water bodies are not unified by a common land cover type and vegetation. This study aims to identify the most suitable multispectral remote sensing indices and threshold values which are suitable in a wide range of scenarios. With this as an aim, we have two major objectives. First one is the comparison of multiple remote sensing indices for surface water delineation and identification of the most suitable threshold which is robust for a wide range of scenarios. To cover these values, we have study areas including 20 different sites all around India, which have more than 3,000 water bodies with a size distribution of as small as 0.1 hectare to 16,000 hectares. And we have taken a 2 time period frames of pre and post monsoon seasons. The data used is Landsat, and for the difference data or the GPS data, we have used NWIA phase 1 water boundaries. So we have compared the 8 major remote sensing indices, which are commonly NDVI, NDWI, NDMI, MNDWI, NDTI, AWEI, SWI, and MVI. These indices have their different expressions, which uses almost all the visible multispectral index bands. And these indices has been developed in a long time period, starting from early 1974 to present, as recent as 2018. Accuracy measures which have been used are overall accuracy, kappa coefficient, quality disagreement, allocation agreement, and overall disagreement. And and also PDI, that is percentage difference area index is one also we use, which is a difference of remote sensing area minus GPS area by GPS areas. And these accuracies measures were calculated for every indices values from -1 to 1, and their individual quality agreements have been identified. And to identify the true threshold values, which is the accurate threshold values, the minimum quality disagreement values has been selected. This value holds true and is same for the minimum PDI values. So as generally used overall accuracies, they give a wide range of or similar overall accuracy for a longer range of index values. But the advantage hold in this quality disagreement assessment, where we get a pinpoint index values, which is best used for delineation or the true threshold value for delineation of the water bodies. This exercise was done for 3,000 water bodies to identify its true threshold values. And the distribution of the true threshold values across the indices varies like this, where the x-axis is the index values and the y value is the PDI values. So this is the distribution, and if we use the multiple indexes values, we get almost 1:1 line for delineation of the water bodies. So this is actually the box plot or the distribution of the images, where we use median and first and second, third quartile of the values to display the results. So as we can see, the NDVI values should be quite higher values, not close to 0 values. And similarly, different indices values have their different threshold values, which must be used for delineating the water bodies. And to find the best index for the surface water delineation, we have used the sum of the PDI value and the mean PDI value to identify the results. And from this table, we can conclude that AWEI, which is automatic water extraction index, is the best threshold or the best index to identify the water using multiple thresholds. But this multiple thresholds has a wide range, starting from a smaller positive values to up to value ranging to 1.5. So we was as a part of the second objective, we need to find a global threshold or the fixed thresholds which can be used for identification. And thus we have plotted the index values having the minimum PDI values. And we can see that MNDWI values have maximum number of wetlands that can be identified with a single index values, and this single index values comes out to be -0.25. So any water body is greater than the index value of -0.25 should be quantified as the water pixels. And similarly, we have different NDVI, NDWI, NDPI, NDTI, these different values. But if we have to be selected of a single index and a single threshold value, it should be MNDWI with -0.25. In the earlier presentations, in the first session, I have seen a student which has used MNDWI as a index, but he has used 0 as a threshold values, which is incorrect. And we can see in the consequential slices what is the effect of the different threshold values when we see. So this is the performance of the global threshold across different indices. So if we use different indices versus the fixed indices, the fixed indices colors have been shown as single values, but different indices have their different indices values. So a different threshold values give good correlation, but they have to be varied. But if a single threshold value should be used, the MNDWI has the minimum scatter plot or the minimum variance. When checked over different water bodies, we can see that MNDWI's values, fixed threshold values versus the dynamic threshold values have a very small variations, and that can be used. These distributions is also studied with change in the soil type, which is dominantly available. And here is the distribution of different indices with their different threshold value respective to different soils. The study was also taken to different seasons where MNDWI, NDVI within pre-monsoon and the post-monsoon months used as March, April, May, and September, October, November were studied, and the different indices results similar. Distribution was also studied for the water body sizes, and here we can see that MNDWI value closest to 0 is a good approximation for a larger water bodies. But if we have to use a smaller water bodies, these indexes value should be a much lower than the zeros. Similarly, NDVI, which is generally used to be a 0 as a threshold value, is only good for larger water bodies. But if we have to delineate smaller water bodies, the index value should be much higher. See, the similar changes of the threshold values can be identified and seen in the different indices. When comparison of these indices with different sensors, we can see that even if we use Landsat 8 or the Sentinel-2 images, the single MNDWI value with greater than -0.25 give a very good 1:1 line match with a just offset of 0.034 hectares, which is a very small values. So in conclusion, we conclude that automatic water extraction index is the most suitable remote sensing index for surface water mapping using variable threshold. And modified normalized difference water index, that is MNDWI values greater than -0.25 is the best surface water delineation using fixed threshold. Switch channel is very important for delineation of water pixels as both the indices uses switch channel for index calculation. Use of normalized indexes gives added advantage of minimizing atmospheric effect to find suitable thresholds. Index thresholding gives us ability to use long-term Earth observational data to archive for mapping across spatial scale and long time period. And Google Earth Engine app is developed for visualization of surface water extent using multiple remote sensing index and threshold value. Thank you. Here is the link of Google Earth Engine app, which I would like to share if the time permits.
Thank you.
Sir, can you see the page, my web page? Hello, sir. Is my web page available, visible?
No, it's not visible. Just click it. Yeah. Click it again.
Yes, it is.
Yeah, now it is visible.
Okay. So here is the Google Earth Engine app which I have developed, where we can use the marker to select a water body to make areas of our own interest. And then can select a time period or day of the month and sometime and choose the indices and change the threshold values and can find which index values or which threshold value is suitable. And with plot of this, we can get directly what is the area of the water body available in this water in these regions, as well as the satellite image and the water extent images. So with changing in threshold values, we can determine which index and which threshold value is best suitable for this. And the advantages of this Google Earth Engine app is that we can use this app in anywhere all over the world with our selected time series, time and the month of the data. Thank you, sir. With this, I stop my presentation.
Yeah, thank you. Dr. Chaudhary, any observations or any other question from any of the participants?
Sir, just it was a good presentation and knowledgeable to me, especially. So just I want to I have a very small query from Dr. Ashwin. Is there any effect of the bandwidth while selecting the means threshold value?
It will be very much effective in selection of threshold values, but we are mostly trying to use the available data which are available and which is open sources. So in that manner, Landsat and Sentinel is the mostly available data which we have. And while comparison within them, we have found that both of them gives similar or 1:1 wetland or water body areas. So if we go for a multi-spectral or hyperspectral data, then the selection of the bands or channels is important. But if we are using the available data sets like IRS series or Landsat or Sentinel, then this MNDWI index is the best threshold, best
Yeah,
index for
thank you, sir. Thank you.
Ashwin,
Yes, sir.
I'm just curious to know one little thing. Maybe it is a senseless query, but what is the use of using NDVI in
Yes, sir.
Delineating surface water content? Because NDVI is for vegetation,
Yes, sir.
as far as I know.
Yes, sir. Very true, sir. But I have seen papers which have used NDVI also as for delineation of the water bodies. They use that negative NDVI as one of the index parameters to delineate water bodies in synchronous with other indices also. So just to have a larger span of the collection of all the indices.
NDVI, whenever we use, if there is background, like water or a bare surface,
Yes, sir.
then it gives negative.
Yes, sir. Yes, sir. That's why we have an error or
So even if you have a bare earth surface, it will give a negative value, not only water.
Yes, sir.
So I just failed to understand the logic of using NDVI, so I asked. Anyway, thank you.
Thank you, sir.
We have the next presentation, please.
Okay, so the next presentation of Lasyami Sahu, influence of topographic features on flood characteristics in Himalayan catchment. So please share the PPT.
Good afternoon. Am I audible? Hello.
Yes, please. Yes, please go ahead.
Thank you, sir. Good afternoon, everyone. I'm Lasami, and I'm going to present on the topic influence of topographic features on flood characteristic in Himalayan catchment. Flood management is more easier when the causative factor, also the influencing factors, are well understood and analyzed. And in this study, we are trying to analyze the topographic features. This is the overview of my presentation. First, I'll roughly 3 parts. And in first part, why to study Brahmaputra? What is the importance of studying Brahmaputra? And in next, how does the catchment behave? Here, some trend analysis and statistical analysis of the rainfall and discharge has been done. And then, what is the link? Here, different catchment features has been derived, and that has been linked to the maximum discharge. This is the overall methodology where these parameters has been derived with statistical analysis for both precipitation and temperature, and trend analysis has been done. And coming to the derivation of different catchment features, we have taken Alos 3D DEM, which is freely available with 30-meter resolution, and using the ArcMap 10.8, we have calculated all these catchment features like area, slope, aspect, elevation, relief, stream density, and first and fourth order stream order. And with a for discharge at Brahmaputra is the transboundary river. We have taken the simulated data set from RICE model, and discharge which are greater than the 2-year return period has been correlated with this catchment features. First is why Brahmaputra. As it is a transboundary river, the floods in Brahmaputra not only affects the people of India, but also it affects the people of Bangladesh and Bhutan, etc. And the part of the Brahmaputra, which the southern basin of the Brahmaputra, that receives almost double the rainfall that received by the northern part of the Brahmaputra. And the average annual rainfall received is 2200 mm, which is quite large. And also this area has a complex topography, and many studies show that this complex topography adds to the extreme precipitation in this region. So here we are trying whether this complex topography is influencing the flood characteristic directly or not. And as we know, the northeast part of India is nothing but the mixture of this eastern part of the Great Himalaya and the Brahmaputra and its tributaries. And so that area is it is filled with many plateau, highlands, and also the Brahmaputra Valley. In few area, the average elevation in plateau area, it is 3,500 meter above mean sea level, but in valley level, even it is less than 100 meter. So this area also receive extreme rainfall due to northeast monsoon, southwest monsoon, westerlies, etc. In addition to that, this area also creates extra moisture to the atmosphere through local evapotranspiration and precipitation cycles. These are studied from the previous studies. So in these events occurs in a specific hydrological condition. So also few researchers studies that this part of the Eastern Himalaya it provides enough scope for researcher for as it behaves as a region of microclimate. So we are trying apart from extreme rainfall, whether this topography also contribute to extreme generation of extreme floods. As I told, few statistical analysis of rainfall has been done for all the 56 catchments of the part of the Brahmaputra basin that falls in India, and trend analysis of both rainfall and discharge has been done in two parts, like 1940 to 1961 part, and this part has been separately analyzed because from previous literature we observe more wet events were observed in this region. That's why, and though all the catchments are very closely packed and part of a larger one basin, still the trend of both rainfall and discharge are different in all the basins. So also trend of discharge and rainfall were not similar. So it indicates that apart from rainfall, other factors also influence highly to the discharge. And coming to different catchment characteristic, all 56 basins we have analyzed, but particularly a few larger basins I have shown here, like with the area in meter square. And area also contributes largely to discharge. As we know, more the area, more will be the contributing rainfall points, and more amount will be contributed to the outlet. And elevation and relief also has been counted, and relief is the difference between the maximum elevation and minimum elevation. It will help in collecting the rainfall more faster. Rainfall will be collected in the channels, which will make it overflow, which will be contribute to floods in positive way. Also the slope and aspect, and aspect is the direction of slope, like how the land surface or the hill terrain that receive the sunlight. And this also influences it plays a major role in soil moisture and stream flow generation. Also the slope map in draining out the if channel slope is less and catchment slope is more, then it also contributes positively. Positive correlation it shows with the discharge, like the stream density and stream order. Stream density, this drainage network, these are nothing but the signature of the past behavior of river in that particular catchment. And more will be the drainage density, less will be the permeable area, and less will be the infiltration. So contribution to the groundwater will be less, and its contribution to the surface runoff will be more. Similarly, stream order has been also given importance because for the lower order stream, that is the first order stream we have taken, that will collect the overland flow from the surface to the channel. So more this number will be it will contribute to more to flood. But as the percentage of higher order streams, that is fourth order stream, will be more, then it will make the outlet of the water more easier, like it will drain out the water more easily from the out of the catchment, so it will reduce the inundation time. So finally, all these catchment characteristic has been taken, and these are correlated with the maximum discharge. And as we can see, the first order stream showing the very good positive correlation with the maximum discharge, and fourth order streams showing negative because it will easily evacuate the water from the channel, and first order will contribute to more water in the channel. And also this mean discharge and mean rainfall also contributed positive correlation to the maximum discharge. And here we can see, like, maximum rainfall is showing negative correlation and it is low also. So if there has been chances that we don't know, we are not aware of the subsurface storage in this area, And as it is a complex topography, the geology are also complex. And here we didn't consider the soil moisture part, and we don't know how much water is being conserved in subsurface region and how much water is being reserved by the deep forest as a soil moisture. Or also there is a chance that water might have taken more time from direct rainfall to come as a base flow. So all these factors will be considered in further coming time in this extended study of this extended part of this study. And as of now, this is the my conclusion. And as from correlation matrix, we can see mean rainfall, percentage of fast order stream, area of watershed, stream density, and stream length has a positive relation with maximum discharge. And more number of parameters of different basins to be considered for better conclusion. I welcome any suggestion. If there are few references, I welcome any suggestions and questions. Thank you.
Thank you. Any observations or questions, please?
Rahu,
Sir,
I'm just interested only to know which are two major characters or characteristics you studied, which has a direct influence on flooding, because that was your title.
yes, sir. Sir, apart from
Is it
rainfall,
maximum discharge or elevation or whatever you want to tell?
sir, it is the drainage density, sir. I mean, particularly drainage density will put more. Sir, particularly to drainage density will give more importance because inside drainage density also will particularly give to lowest order stream and highest order stream, sir, because these two are showing, one is showing maximum positive correlation, another is showing maximum negative correlation. This negative is not lowest, but it is also related in a negative way, like inversely proportional way. So these two things, particularly drainage network, inside drainage network, first order stream and fourth order stream, by giving more priority, sir. So we can conclude that in Himalayan catchment of Brahmaputra river basin, drainage network play a major role apart from extreme rainfall in flood, maximum flood, sir.
Just if there are no other questions, can we move to the next speaker?
Yes,
Sir,
we
one
should.
question from my side.
Yeah, please. Go ahead.
So, can you tell what is the impact of the land use on this flood? Because land use plays a major role, and
Yes, sir.
only changing thing is land use. All other things are, I think, constant or that much not changing. So, have you evaluated the impact of land use?
Sorry, sir, I didn't evaluate the impact of land use, sir. So as many factors are there, influencing factors are there. One is land use, sir, very important factor, I agree. And we are focusing on topography features only, sir. And it is not changing, that also true. And we are also not evaluating every year how it is changing. We are just evaluating like in addition to rainfall, how the even if same rainfall is occurring in two basin, I mean, how the topography influencing, how the drainage network is influencing the highest discharge. So I didn't study your land use characteristic.
Okay,
Only
thank you.
topographic features.
Thank you.
Thank you, sir. Thank you, sir.
So, sir, our next presentation will be from Dr. Shashikant Patel. He is presenting on the topic of development of web-enabled water resource information system of Punjab using open source technology. So, Dr. Shashikant, sir.
Yeah, good afternoon, sir. Good afternoon, everyone. Yeah, am I audible to all?
Yes, yes. Good afternoon. Please go ahead.
Yeah, yes, sure. Yeah. So my topic is development of a web-enabled water resource information system for Punjab using open source technologies. Here we have developed a open source based WebGIS system. The authors are myself, Baljit Kaur, Sonam Verma, Pradeep Kumar Luturia, and Dr. Bijan Patel. So, yes. Yeah. So introduction is there. This is the need for water is universal. Water is present anywhere, and without water, life, as we know, it will simply cease to exist. Uh, the high rates of urbanization and increasing demand for drinking water is inputting stress on the existing water sources. The mounting challenges posed by the challenging demand for and supply of the resources highlights the importance of water in any development growth agenda. So the web GIS and GIS technologies, a combination of GIS and internet technologies today, it brings an one step closer to visualization of the complex pattern and relationship of heterogeneous data. Heterogeneous means the different formats, different sources, and the means uniformity of the data. So WebGIS describes real world situation in visual, dynamic, and interactive format, which is pertinent to monitoring of various indicators and features. Sir, the system is combined with the water resource management, geospatial technology, and water resource data set. So the objective we have formulated to develop this system, design and development of the open source based WebGIS portal to disseminate the information related to the water resources. This is to develop, establish, and implement a WebGIS based single gateway where integrated GIS platform to access, acquire, process, store, distribute, and improve the water resource information within the unified system. This intelligent web service publish the spatial data set along with advanced tools for GIS-based analysis, segment specific solution to the government for governance in water resource planning and management. So that system will be very useful for the planning and management from the government perspective for the governance. So this is our study area. Under Punjab state, we have taken and we have collected the data set from the various projects. We have formulated in a single platform. So as you all know that Punjab state is a border state. So it's a northern state surrounded by the Indian Union Territory by Jammu Kashmir to the north and the Indian state of Himachal Pradesh to the east, Haryana to the south and southeast, and Rajasthan to the southwest. So I need not to go into the detail. So just I'm going to the tools and technology what we have used to develop a water resource information system. These are the all open source freeware technology which we have used for the development, where for the database, for the storing, manipulating, and updating the data set, we have used PostGIS plus PostGIS extension. It is also an open source database. GeoServer for the rendering the layers over the internet or over the web services. Like the web services, we have used GeoServer. Open layers, these are the rich client library, JavaScript library, which provide the interactive user interface at the user end, right? So Quantum GIS, it is also a desktop GIS software, freeware GIS software, which provides the data processing, overlay analysis, and spatial analysis facility. ArcGIS map, which was initially developed the data initially developed in that platform. UDIG is a system or software you can say to generate the style or symbology of the data set. So the complete technology, open standards we have used like services, open geospatial services, open data set, and open softwares that completely enable the web GIS for the water resource information system. So the technology or system architecture, we can say that we have implemented, we have comprises the data in two blocks. First block is administrative boundary. Another one is the water resource data layers. So administrative boundary to define the jurisdiction where we want to analyze anything or any layer or any water resource, and the water resource layers which was collected, which is collected from the PRSC, which is means developed or designed in various projects by the Punjab government or by the central government, by the Department of Space, right? So we have pre-processed all the data set to define the uniformity, projections, and formats, styling, etc. Then we have ingested that data set into the PostGIS SQL with the PostGIS. Then the GeoServer acts as a GIS server to publish the layers into to the users. And some data set which are the not a special data set that is published single means separately directly to the web server. So the request comes from the user in the form of maps, charts, table, reports, or special layers that goes to the web server. Web server communicates with the GIS server or database, and it again responded to the users. So the system, the GUI here we are showing, we have comprises the layer watershed region. 2 regions were defined for the Punjab. Watershed basins, 4 basins, and watersheds, 32 watersheds. Dams and reservoirs, 18 have been mapped. Water level samples have been collected for 3,038 locations. So this is the unified system and user interactive systems we have developed. So you just select the particular layer or a particular special data set here. This is the panel where you can select. I will show you. So these are the water level sampling locations. Here it is water level selected, and all the water level will be shown to the user. So he can zoom in, zoom out, or pan, or with some information like if there is a well. So with that well, within the 5 kilometer distance, how many wells are there? Or with that particular location, how many wells are or other water resources are there? Canal and drainage systems over the Punjab, that is also shown in the map in the system. So this is the watershed basin, and user can click on the particular basin to get the information about the basin. So this is, and here it is, if user wants to choose the particular district or particular data set, then he or she can select the particular district, then that map will be zoomed to that particular location or basins, right? So we have also given a special query builder for the user. Suppose I want, somebody wants to search the how many rivers or canals in my particular area. So he can select and generate a special query in the system and click on the apply. Then he or she will get the results with the specially analyzed results, right? So ultimately, I'm going to the conclusion. So that system has been developed at PRSC, and this study. One can draw the conclusion that WebGIS is a prospective application in GIS and represents an important advancement over the traditional desktop GIS. So initially, we can say that the traditional GIS system, individual users are analyzing the data, and they are, whatever the interpretation, they are saying that the somebody or the governance has to be accept or rejected, right? But it is the system where anybody can see the results or see the special layers over the Punjab or analyze the particular theme, right? So it's an application that eliminates the duplication and inconsistency and makes the location information conveniently and intuitively accessible across the organization at lower cost per user. So the internet provides a medium for the processing geo-related information and special information to the users to an amount larger than the traditional GIS. The study lays the foundation of proper management of the water resource. It adds in realization and the social strategy under the Punjab state in developing water resource planning and management. So this WebGIS will be very helpful to share data and retrieve the results from the procedure optimizing for the managing water resource in Punjab state. So thank you, sir. This is our development work for the water resource information in Punjab. So any question are more welcome.
Yeah, thank you, Dr. Shashika.
Yes, sir. Thank you.
One or two observations here.
Yeah. Yeah.
You have various data sets, and you have further formed certain layers whereby we can have a query.
Yes, sir.
I just want to know whether can we have basins or sub-basins based on the major canal systems?
Sir, right now, whatever the data set we had in PRSC that were mapped in the system, But yes, if the means we can find out or we can map that subbasins, that can be also integrated with that system.
Yeah, that is required, number one.
Yeah,
Number
yes.
two, you see one link missing is the rain gauge stations. Because rainfall contributes to our water resources in a significant manner. So the
Yes, sir,
location
sure.
of rain gauge stations is very important. Second is use of treated water. For managing the treated water, you need to have all the STPs mapped.
Okay, sir. Sure.
You see,
sure.
because when I worked as chief conservator soils, the issue which I faced was that we get the treated water at STPs 24/7, 365
Right.
days. Now, our irrigation requirement is just for 90 to 120 days.
Right.
So where to take the treated water during the non-demand period? So in case we can have a layer whereby we have the STPs, the capacity of the STPs, which are treating the inflows, and then where to take that water and store it. So drains are the best places where we can store the treated water, and we can have small check dams there, and that can be stored. That will contribute to the groundwater recharge, as well as that can be lifted for irrigation purposes also.
Right.
So I think we
Sir-
need to work further on this.
Sir, I think it's a right platform to request you. If we can have the list of STPs in Punjab, so that can be mapped by ourselves.
Sure, you'll get all those, and
Yes,
I'll sit
sure.
with you, and I think we can further improve this. This is an excellent exercise which you have carried out, and I think we need to further scale it up.
Sure, sir. Thank you with my pleasure.
Thank you. Dr. Chaudhary, any observations or any other question from any of the participants, please?
Sir, I have just one query. It's not a question. I just want one query that do you have any web-based system that give us information regarding the aquifers?
Aquifers.
Yes, I think it is
No.
it's our basic need to improve our water quality to the people giving the water giving to the people of Southwest Punjab. Any web system that given information regarding aquifers?
I understand, Shatvi sir. Just we have another web portal for the Department of Water Supply and Sanitation, where the water quality has been mapped in 2016 or 13. I think, right, sir? So that there is no aquifer details. They have some observation wells, right? So the observation wells with height and quality that we have, and that we can share with some official process.
Okay.
Let me answer his query. Sameer, there is one aquifer mapping program carried out by Central Groundwater Board.
Okay, sir.
So they have mapped the aquifers of Punjab up to 300-meter depth.
Okay, 300-meter depth.
They have delineated the aquifers up to 100 meters, from 100 to 200 meters, and then from 200 to 300 meters.
From different depths.
So till 300 meters, they created these water fields.
Okay.
From that, all the aquifer parameters were mapped, and somewhere around, as per my knowledge, 36 water wells were installed.
In overall Punjab?
Overall Punjab, yes. So, and based on that, they have computed the aquifer parameters and the available water, the available groundwater at different depth zones. So from 0 to 100, 100 to 200, and 200 to 300 meters.
From particular depth intervals.
Yes. So the total water availability up to 300 meters is somewhere to the tune of 299 billion cubic meter.
Okay, sir.
So that data is available with Central Groundwater Board. If you need that data, or in case you need any further query on that to be replied, so you can contact the Regional Director, Central Groundwater Board.
Okay, thank you. Okay, thank you, sir. Thank you.
Okay, thank you, Shashikant sir. So our next presentation will be from Satvir Singh.
Yes, sir.
And the presentation.
Sir, first, sir, there's a small request to all of you that the abstract of my both presentations are correlated with each other. And there's the abstract of first presentation is about the distribution of uranium. And in other abstract is the remediation part. So I want I club both abstract in single presentation. Is it okay or not?
It's okay, please go ahead.
Okay. The title of my presentation is based on comparative analysis of spatial and depth-wise distribution of uranium in groundwater of Bathinda and Amritsar district. And the other one is treatment of uranium prevalent water using society-head functionalized amino mesoporous silica to achieve safe water resources. This is the general content of my whole presentation. In introduction, uranium is a natural radioactive metal having both radio and chemical toxicity, and it's also a stable one. The +6 oxidation state of uranium is highly soluble among the other primary oxidation state of uranium, that is +6 to +4 +3, but +6 is most soluble one. The possible routes of exposure to uranium in human are the ingestion through the food and drinking water, and other one is inhalation through air. So the prominent sites of uranium deposition in the human are kidneys, liver, and bones. So the epidemiological and toxicology studies confirm that the exposure to uranium leads to nephrotoxic effects to the human. That's why, because of its toxicity, maximum allowable limit set by WHO for content of uranium in drinking water is 30 microgram per liter, whereas the limit set by ARB is 60 microgram per liter. This is a study area of the present study. One is the Amritsar district, and other one is Bathinda. One is from southwest Punjab, that is Bathinda, and other one is from northeast, that is Amritsar. The collection of sampling is totally based on a 6x6 grid pattern, and an average of 2 or 3 samples from each grid was taken from different depths to analyze the study of both spatial and depth-wise distribution of uranium. Methodology for sampling, as we already discussed, that the sample collection is totally based on 6x6 grid pattern, and the pH TDS of fresh water samples are measured immediately on the sampling site. And for measuring of measurement of total alkalinity, the titration method was used, and estimation of uranium content in water is analyzed using LED fluorimeter. That's a good technique. Then the spatial distribution of uranium in Bathinda and Amritsar district. As we observed clearly from the left panel, that is of Bathinda district, it looks most of the sampling location have more concentration of uranium. It is obtained from experimental data that uranium concentration vary from 2.12 to 491 microgram per liter in Bathinda, which is quite high, and quite high as compared to the Amritsar, where the uranium concentration varies from 1.36 to 64.19 microgram per liter. And the average content of uranium was found to be around 83 in Bathinda and 7 in Amritsar, 7 microgram per liter in Amritsar district. The statistical variation of TDS. It is clearly seen from the bar graph and from the table that the quite high TDS is measured in the groundwater of Bathinda region. That is why that vary from 108 to 4000. That is quite high and unacceptable. Almost 80% of samples from Bathinda region exceeding the limit of desirable limit of TDS. And these high values of TDS further enhance the mobilization of uranium from groundwater, because the high TDS contain various amount of anions and cations that play a vital role to interact uranium in groundwater. Now, statistical variation of total alkalinity distribution. The higher value of total alkalinity was observed in same as the trend following for TDS. Same trend is followed for total alkalinity. The Bathinda region has quite high value of total alkalinity, varies from 76 to 2040. And bicarbonate, I think we all know that one of the major anion which enhance the mobility of uranium groundwater. So uranium can easily make complex with carbonates and bicarbonates in the pH of 7, 8. It's a that we all get the groundwater in that particular range of pH, and at that particular pH, uranium can easily make complex with carbonate and bicarbonate and get soluble in oxygenation of +6. This is the depth profile distribution of uranium. As represented in pie chart, uranium concentration around 78%, 40 and 38%. There's almost 78% of samples are exceeding the limit of WHO, that is 30 microgram per liter, when depth is up to 350 feet, vary from 50 to 350 feet, and on further increasing the depth from 350 to up to 500, 800, and the value is fall from 78 to 36%. Only 36% of sample are exceeding that limit, and only 1% of sample of Amritsar district are exceeding WHO limit when depth is more than 350 feet. From this bar graph, it is clearly observed that high concentration is only in the shallow aquifer, that is from up to 350. Similar trend is for Amritsar district, and the concentration of uranium is decreased with increase in depth. The maximum mean uranium content was observed in the depth range of 150 to 350 feet in both the district. For conclusion, the first part of abstract, the average uranium content were found to be more for Bathinda compared to Amritsar district, and the average TDS and total alkalinity was found more in Bathinda in comparison with Amritsar district. The positive correlation with the uranium concentration, TDS, and total alkalinity because they contain more ionic species, and they give they mobilize uranium from the water rock interaction to the soluble condition to the groundwater. It is also observed that shallow groundwater has high uranium content as compared to the when depth is increasing. The shallow groundwater has more content of uranium. Now, for the sake of environmental sustainability and human health, it is necessary to make an efficient adsorbents to remove uranium from the groundwater. And the mesopore silica are the emerging material nowadays because of their hexagonal honeycomb-like structure, and the common types of mesopore silica are MCM41, SBF50. And the MCM41 is the family of silicate group and form templates from micelles to build up a mesoporous framework. And the intrinsic property like highly porous, large surface area, and abundant functionalities make them a strong candidate for their real application for adsorption, gas separation, and sensing. This is the schematic representation of the synthesis of the MCM. The initially amino MCM41 was successfully synthesized and then further grafted with sessaldehyde, and the prepared material further examined for removal of uranium using batch mode adsorption study. At last, they apply for real application as column studies and batch mode studies. For the characterization of the prepared materials, first small angle X-ray diffraction was carried out to examine the mesopore structure of MCM. The sharp refraction at the around 2.02 indicate the highly hexagonal mesostructure, and for surface morphology and elemental composition and the presence of uranium on the surface of MCM, FSM analysis and EDX analysis were carried out, and before adsorption of uranium, the surface of the prepared material looks quite rough and heterogeneous, and after adsorption, the surface become more dense because of the adsorption of uranium on the surface of the prepared material. And the EDX analysis before adsorption, the particular distinct peak of silica, oxygen, carbon, and nitrogen is visible that confirms its chemical composition. And after the adsorption of uranium, the distinct peak of uranium also visible that give us a gratifying evidence of confirmation of removal of uranium on the surface of MCM. For analysis of the adsorption behavior of MCM, various experiment conditions like such as pH, contact time, adsorbent dose, initial metal and concentrated ionic strength was examined. First, as shown in figure, the MCM was found to execute best at 6 pH, and the dose, optimum dose is 0.4 gram per liter, and the optimum time, and then at 30 minutes, and then it will become equilibrium. Similar, and when we increase the uranium concentration, the efficiency is decreasing because of the fact that at higher uranium concentration, more uranium ions compete to occupy the limited number of available sites. And the last one figure represents the independent nature of adsorption of ionic strength. Then the isotherm and thermodynamic models are used to identify the actual mechanism of the adsorption process. The adsorption process, actually, sorry, there's a problem. It's visible, sir?
Yes, yes.
Yes.
This isotherm and thermodynamic model, as shown in figure, that the absorption process fits better to Langmuir that reveals the monolayer coverage of the uranium on the surface of the prepared material, that there is some mistake. There is not GIFs, it's a MCM. And the positive value of delta H, that is enthalpy and entropy, indicate the process is endothermic, and the negative value of Gibbs free energy reveals the feasibility and spontaneous nature of absorption. Now we prepared that material, but then further we analyze its practical application on real uranium prevalent water sample, that is from Bathinda. We choose 10 samples from Bathinda and carried out the suitability of the prepared material as packing component in water treatment system. The column pack system provide another benefit because it gives the water instantaneous as compared to batch mode, because in batch mode we set the optimum time as 30 minutes. And what we observed that when the initial concentration is around 163 up to this, also the sample having concentration around 475, these both studies give up amazing results and give the water around almost 10 to 5 or 10 microgram per liter, which is within the allowable limit. And this is the material. And at last, I acknowledge my supervisor by B.S. Vajwa, Ma'am Inderpreet Kaur, and Dr. P.K. Lutoria, providing the GIS special distribution data. Thank you, sir.
Thank you, Satvir. Any questions or any observations? Dr. Chaudhary, any observation from your side, please?
Sadhbir, Mr. Sadhbir.
Yes, sir. Yes.
Worked on uranium, and nice to know the ranges. Different. I missed a small part of your first presentation. How many samples did you take from each site?
So it's around 180 sample from Bathinda region and around 120 from Amritsar, because the Bathinda is quite large in the as a area wise as compared to Amritsar.
Now my main question. You worked on the total alkalinity and you talked of the relationship of bicarbonate with the uranium solubility, right?
Yes, sir.
You didn't present that bicarbonate values. You just gave total alkalinity. It includes many other things.
I just include the TDS and the total alkalinity. Only bicarbonate, carbonate, and the TDS cover all, but I just also measure the nitrate, sulfate, but don't present it in this slide.
Can you listen to me? TDS is a no indication or no indicator of bicarbonate.
Yes, sir.
The index of total salts, soluble salts available. And bicarbonates are not known to be the total soluble salts. They are in fact measured by RSC or bicarbonate as such.
Sorry, sir. There's some interruption in the net. Please repeat your question, sir.
A TDS is no indication of bicarbonate concentration in the water.
Yes, sir.
It can be related to at least at the most with EC, electrical conductivity. But you have I thought, and that would have been really good if you could have analyzed bicarbonate for each sample and made a correlation between the uranium concentration.
Yes, sir.
What you said is just you
for bicarbonate. I made total alkalinity, not TDS, sir.
You said about bicarbonate, but you presented total alkalinity. So that is a big mismatch, and moreover, you should have given that correlation, because bicarbonate concentration in Amritsar waters would be less, and the correlation would have made more sense, and the study would have been more impactful.
Okay. Thank you, sir.
And secondly, when you are using an adsorbent, right?
Yes.
In the second part of your presentation, to reduce uranium concentration.
Amount of uranium.
Yeah, in one of your location in Bathinda, out of 10 locations, it has in fact increased from 70 to 100 adsorbent.
Just a wait, sir. I just open it.
In Delma or something, some word. I just missed that location. That's just a part question. My main question about this is, how would you then recharge those adsorbents again? Where would you put that uranium rich?
Actually, sir, the prepared material also have
It's
good
not nothing related to your presentation, anyways. It is a practical part. Just I want your observation. Number 9. Number 9.
These prepared material also show a good regeneration ability. When we dilute it in the 0.1 HNO3, the uranium then dissolve from the surface, and we again reuse it in 5 cycles instantaneously. And after 5 seconds, it also
Where are you putting it back? My question is, anyway, it's not part of your research. That's another, that's the extended question. But my main question, number 9 location, Telva
sir.
is 70 to 100. How can it happen?
It's a 70 to, it's a, other is 100%. It's a efficiency.
Right?
It's a efficiency. So there's initially it is a 70%, 70 microgram per liter uranium concentration in water sample of Tilma, and when we examine it in the batch mode study, it remove almost 100%. It give a final concentration of uranium around 0 point something.
No, you should have given those values. It is just confusing table.
These are percentage values. Sorry, I missed it too.
Table altogether. It's different. Because I tell you, 97% of 500 and 97% of 70 will be much different. So
these are
please,
percentages, absorption efficiency.
Nowhere written, and moreover, it's a confusing table. It doesn't help the reader to get to tell what you want to tell them.
Okay, sir. Next time I will improve it.
Okay, it's okay.
Any other question from any participants? Yeah, Satvir, I have one observation.
Yes, sir.
As per your studies, you say that shallower aquifers contain higher content of uranium.
Higher content of uranium.
Whereas the deeper aquifers are showing lower content.
Yes, sir.
How did you draw your samples? Did you use the existing tubes or the hand pumps?
Existing tubers, sir.
Existing tubes. So that means
that tubers in from the fields or from the houses.
Yeah. So most of the tubes installed in Punjab, the issue is that they are tapping all the aquifers.
Yes, sir.
So it is possible that the deeper aquifers may not be containing any of the uranium, and the contribution is coming from shallower aquifers, because whatever samples you have drawn are aggregate. So you are getting water from all the aquifers.
Okay.
So I think your studies will make more sense if we can install some sealed piezometers depth-wise.
Okay, sir.
So only then we'll come to know the uranium content depth-wise. So the studies which you have carried out do not clearly define the depth-wise uranium content. This is my observation.
So what which thing is feasible for me that I collect the sample from that places?
No, moreover, historically, Sadhbir, continuing with Dr. Vishesh's observation, it has been like in Freeport and parts of Bathinda earlier, study made by a scientist of our department show that the uranium present there or sitting there in the soil is geogenic. It is sitting there for long. And what you're saying, and Dr. Vishesh rightly pointed out, it should not have come more from the shallow water.
Actually, sir, there's a. I just want to add some point.
You should know where it is, where uranium. Otherwise, what are you saying means? It means it is the fertilizer inputs which is.
No, sir. The actual source of uranium is geogenic.
No. Then it should be logically.
You raise a point that it is in shallow water. I just want to add some point. There's a some condition like overexploitation, that we are using the rice crop, those when we exploit the water from the groundwater, it create a toxic condition. We are I think the normal bore wells are in the about depth of 2 or 300 feet. The overexploitation in particular that depth create a toxic condition that make uranium mobilize from water rock interaction and get dissolved in that water. It may be one reason, but I am not saying that the reason of the source
Even if
is
Sadhvir, we have to conclude it now. My point is, if even if what you say is agreed upon, then it should be diluted, or it should have gone lower by sheer dilution, because more water we are removing, it means more uranium is moved out. It's not the case.
Definitely.
So don't make speculative conclusions. Rather, we have the data, or we say we have to work on it.
Okay, okay.
See, what you are saying is, अगर पानी ज़्यादा हमने निकाला है, तो यूरेनियम भी ज़्यादा निकला होगा ना? Do you agree?
बिल्कुल निकलेगा सर।
मोर डीपर जा रहा है, तो डीपर आप कह रहे हो डीपर कम होना चाहिए।
नहीं, एक्चुअली मेरा क्वेश्चन ये था कि सर जस्ट अ पॉइंट कि हमने जो ज्यादा वो ट्यूबवेल हैं वो पर्टिकुलर एक डेप्थ पे हैं 200 और 300 फीट में। अभी हम मतलब मोर डेप्थ में इतने नंबर ऑफ ट्यूबवेल्स नहीं है, और ओवर एक्सप्लॉयटेशन अब जो है वो पर्टिकुलर उस शैलो एक्यूफर में ही है। वो एक कंडीशन कर देगा कि जो रॉक्स में जो जियोजेनिक रॉक्स हैं, ग्रेनाइट रॉक्स में, मे बी ग्रेनाइट रॉक्स, वो उसमें से उसको मोबिलाइज करके वाटर में सॉल्वर कर देगा। अभी हमारे पास 700, 800 या 1000 फीट में इतने बोरवेल्स नहीं है एज कंपेयर टू द नंबर ऑफ बोरवेल्स इन पर्टिकुलर 200 और 300 फीट।
Satvir, you need to refer to more studies which have been carried out. Punjab University has carried out a lot of studies on the occurrence of uranium.
Okay, sir.
And the source is geogenic. There's a ridge cutting across Punjab, which is known as Sargodha Delhi Ridge. You need to study that. It has clearly established that this granite ridge is contributing to the southwestern part, where the native groundwater was contaminated with uranium. And because of certain conditions and the water logging, it has traveled to the shallower aquifers. And as Dr. Chaudhary pointed out, that the uranium is lying in the soil, and maybe because of the evaporation at shallower depths, it is being found there. So you need to refer to various studies carried out. Even Geological Survey of India has published a report whereby they have taken samples from Sangrur till Bathinda, and it has been clearly established there are certain pockets where uranium is existing. So I think you need to further refer to those studies and improve your presentation.
Okay, sir. Thank you, sir. Thank you.
Okay, thank you, Satvir. So before closing the session, I would like to have a conclusion from chair and co-chairs. So, sir.
Dr. Chaudhary, I think you may.
Yes, well, you want all the speakers to stay if we make our conclusions?
Yes, sir. So conclusion for this session.
Okay. Before Dr. Vishis takes over the stage, I thank all the speakers for making nice presentations about different different aspects of water resources, starting from snow melt contribution in Upper Jhelum by Mr. Azaz Ahmed Pare, and glacier inventories studied by Tariq Abdullah. And then we moved to Mr. Ashwin Gujarati evaluated the performance of multi-remote sensing devices in delineating surface water content. And Ms. Sahu then worked on rather tried to work on the influence of topographic features on flood characteristics in Brahmaputra, Himalayan catchments. And Dr. Shashikant Patel made a very relevant presentation on the web-enabled water resources information system in Punjab using open source technology. And Mr. Sadhvir at the end made the comparative analysis of spatial and x-wise distribution of uranium in groundwater in Bathinda and Amritsar, and then the strategies or treatment of reducing uranium in water using salicylide functionalized amino mesoporous silicas. And in all, they were all good presentations, and when they made some, they made us think about what should I say, the contributions of water resources and need to manage more water resources in a better manner. I congratulate all these speakers for making nice presentations.
Okay, thank you.
Thank you, Dr. Vishist, for your comments, please.
Thank you, Dr. Chaudhary. I congratulate all the speakers, especially you see, water resources are very important for development of any society. All the civilizations have developed because of the water resources, and even vanished because of the water resources. Mohenjo-daro and all other civilizations which have vanished are the examples that how important our water resources are, mainly for states like Punjab and the adjoining states of Haryana, even J&K. So the presentations made by our speakers from Kashmir, Ajaz Ahmed and Tariq Abdullah, they are very relevant in today's scenario, because you see the snow melt and the glacier inventories are very important, because the kind of situation we are into, this is resulting into kind of flooding and drought situation because of the climate change. The glacier line is declining, it's receding. Even the depths are varying at certain places. There is erratic kind of trends in the snowfall and rainfall. So we need to manage our water resources, how the storages are going to work, how the dams are to be operated. So these studies are very relevant. Then the presentation made by Mr. Ashwin Gujarati about the comparison of performance of multiple remote sensing indices. That's also very important, because we need to map our and delineate our water resources, the surface water resources. Then Brahmaputra is a big pain because a lot of floods are there, and the topological and the topographic the topography contributes to that. And as one of the speakers pointed out, that land use plays an important role. I think Ms. Sahu would incorporate the land use into her studies as well. Then a very relevant presentation by Dr. Shashikant on development of web-enabled water resources information system of Punjab using open source technology. He presented the tools and it was an eye-opener that all the water resources are being integrated at one place, and I think we can further improve that. And that will be very important for the governance and the planners, and it can really contribute towards management of the water resources of Punjab. Then Satvir presented the comparison of uranium and its treatment. And I think all the speakers need to be congratulated. And the Ludhiana chapter of Remote Sensing Center, they need to be congratulated on holding this session on water resources. I congratulate all and thank you all. Thanks.
Thank you,
Thank
sir.
you. Thank you.
I would like to share a vote of thanks, a memento to our co-chair, Dr. Om Prakash Chaudhary. Then I would like to share a vote of thanks, a memento to our chair, Dr. Rajesh Vashisht, sir. Thank you, sir. Thank you, sir, for being with us for this session.
sharing it very nicely. Thank you, Dr. Vishesh.
Thank you, Dr. Chaudhary. Thanks a lot.
Thank you.